this TestNG video playlist. I am your instructor, 𝒃𝒐𝒏𝒆𝒔 II. You can follow me on YouTube, LinkedIn, Facebook, Twitter, and GitHub. All of the source code will be on GitHub. You can go to my website at 𝒃𝒐𝒏𝒆𝒔2.com if you want to see my books, blogs, and other videos. In this tutorial, we will walk through step by step through some TestNG features. The features start with annotations. After annotations, we will create our first test using Selenium and TestNG. Then assertions, followed by parameterizations. We are going to parameterize our test using the parameters annotations. Next is taking a screenshot of an application, but only take the screenshot if the test failed. When it comes to dynamic wait statements, they are Selenium features that I will combine with TestNG. The next tutorial is super important, and that is the page object model. It is not a framework, but it is a design pattern that is part of a framework. The benefits of a page object model include code maintenance, code maintainability, and code reusability. The last 3 tutorials consist of parallel testing. In that same tutorial, I will also demo data providers, then cross-browser testing using TestNG and Cloud Selenium Grid. We will close with geolocation. Before we get started with the features, let me first introduce TestNG. What is TestNG? TestNG is a test framework for writing test scripts and running test scripts. The purpose is to inspect the testing process of an application. Test frameworks are important because it simplifies the process of testing. They simplify the process by making it easy to run a quick test. Another way test frameworks simplify the process is by providing the ability to run our test as a collection. The 4 core functions of most test frameworks include creating and executing test scripts, generating test reports, generating test logs, last but not least, reading and writing test data. The complete name for TestNG is Test Next Generation. It is the next generation for testing, and it includes many features for testing, such as parallel testing, integration testing, dependency testing, data-driven testing, cross-browser testing, end-to-end testing, and other types of testing. We can set up TestNG more than one way. However, I would use IntelliJ to set up our tests, and we will see Maven as the default when clicking New Project. We can also click Gradle to set up TestNG. Now we click Next. Provide a name like Tutorials TestNG and finish. Inside of the pom.xml file, we should see the properties tag. The property tag compiles our code. Now, after clicking the properties tag, we must add the dependencies tag by clicking the left angle bracket, then selecting dependencies. The shortcut way to type a dependency and add dependency is to click the angle bracket again, then select dependency. For the shortcut, we will add the dependency name inside the group ID or the artifact ID. Let's use the group ID. Inside of it, hit Control Space, then add the dependency that we want, and that is TestNG. Select org.testng, then select the version, 7.4.0. Now we have the TestNG dependency. Let's also add 2 more dependencies. And those dependencies are Selenium for automation and WebDriver Manager to automatically manage our drivers. When using Maven, we can also go to MVN repository. This site has many dependencies. Search for Selenium 4. And after we see Selenium 4 after searching, there are many options. At this point, sometimes people get confused because there are many Selenium options. I will select Selenium Java because it also includes other dependencies such as Selenium support, Selenium Chrome driver, and other drivers. So Selenium Java takes us to the version part. We see 4.2.2 is the latest version, but I'm going to select the official first Selenium 4 version. Then copy the dependency. Go back to the IDE, then paste the dependency. Now we have Selenium Java. For WebDriver Manager, let's use a shortcut by clicking the angle bracket, dependency, inside artifact ID, I'm going to hit Control Space, then type WebDriver Manager. And for the group ID, I'm going to select io.github.𝒆𝒏𝒆𝒔. For the version, 5.0.3. If you have any issues with your Maven project for its loading and you see any red lines, you can load the Maven changes. Control-Shift-O is the shortcut. Now we are finished setting up our TestNG dependency. We're finished setting up Selenium and WebDriver Manager. Next is the TestNG annotations. A TestNG annotation is data that have a special meaning for a Java method. Our execution flow depends on the annotations. We will look at the TestNG XML file to understand the execution flow for a suite, test, class, and method. In the IDE, we will look at the TestNG package for the directory of annotations. There are many annotations, but we will focus on the test annotation and configuration annotations. The test annotation identifies our test method. A configuration annotation always starts with before or after. They are called configuration annotations because each annotation performs an event before our test and after our test. For a reference AUT, we will use Selenium Playground from LambdaTest. Our mark test is data pickers, date pickers, and list box. Bootstrap date picker, jQuery date picker, Bootstrap list box, and jQuery list box. For our code, we start by creating a package under Test Java. Right-click Java, New Package. Name is Demo TestNG. Now we create a class by right-clicking Demo TestNG, New Java class. Name is Configuration. Annotations _1_date pickers. Let's create one more class by right-clicking Demo TestNG, New Java class. This time the name will be Configuration Annotations _2_list box. In the class, the test begins with an @ symbol, then test. The @ symbol is short for at a rate symbol. Test represents the test script. Public void test1 _bootstrap date picker. Let me update the import statements so it can import all of the annotations and add some lines so we have some room at the bottom. For demonstration purposes, let's use print statements. For the test method, first one, the print statement will be test method 1 bootstrap date picker. We can add more than one test. So by doing that, all we need is to write the add test again, then provide a different name. Test2 jQuery date picker. Change test method 1 to test method 2. jQuery date picker. Now let's run. We have two test methods, test method 1 and test method 2. Both test methods passed. This next part is interesting because in our project, we will set up some events before our test method. One of the configuration annotations is the at before method to set up before the test. Now, for this, I will name it public void before method. The print statements will be execute before each test method. Also, we need to perform some events after our test method. The configuration annotation comes in pairs, and the pair for before method is after method. The name will be after method. The print statement, let's add the print statements based on how they operate, and it executes after each test method. Now let's run to see the execution flow. The console shows us 6 print statements, 2 before methods, 2 test methods, and 2 after test methods. Before each test method, we see an execution statement, then test method 1 and test method 2. After each test method, we see an execution statement. Let's modify these print statements so the console is better for us to read. For the test methods, let's add 5 spaces, 1, 2, 3, 4, 5, and write the number 5. Copy and paste the same information for the second test method. For the before method, let's add 4 print statements, 1, 2, 3, 4, then add the number 4. And I'm going to copy and paste this information for the after method. Do you see the method names before method and after method? These names can be any name. However, the annotations before method, after method, and test cannot be any name because these annotations are strongly typed, so the compiler will flag any mistakes if they are not correct. Recall, configuration annotations are annotations that start with before or after. I prefer to call them preconditions and postconditions. So far, we know how to add an event before each test method and after each test method. We can also execute an event before each class and after each class. We write before class, public void before class is the method name. The print statement. Let's add 1, 2, 3 spaces. Execute before class. The class name is date pickers. Copy and paste. Then change the name from before class to after class. Change the method name to after class. Also, the print statement, it executes after the class. Now, at this point, I'm going to go ahead and run, and let's see what the console shows us. Yes, we see the console. It shows the before class execute one time before everything in the class. The after class execute one time after everything in the class. Yes, and the number 3 print statements shows execute before class dates pickers and execute after class date pickers. That's cool. Most people create the test annotations at the method level. However, we can also implement the test annotations at the class level. So let me show you by copying all of this information. Then paste this information in the next class. Now, at this point, I want you to recognize that we have the method and annotations in a certain order, but TestNG identifies the method by looking up the annotations. Therefore, we can place the annotations anywhere in the class, and they will still execute in the same order. So for demonstration, I'm going to copy all of this information for the configuration annotations. I'm going to cut, then paste them at the top in a different order. Also, I'm going to show you about placing the test annotation at the class level by removing it from the method level. Go up top, before public class, write at test. Now it's at the class level. Also, change the names from date pickers to list box for before class. Now for the after class. Now for the test, I'm going to change test 1 to test 3. Then put bootstrap list box. Test method 3, bootstrap list box. Also change test 2 to test 4. jQuery list box. Test method 4, jQuery list box. Plus, I'm going to add some line spaces. Now, let's run and see how they execute in the same order. The only difference should be the names from date picker to list box. Yes. So we see the class and the methods have list box and they execute in the same order. Cool. Okay, so now at this point, I want to show you another concept, and that's executing both classes at the same time. Let's transition to the TestNG XML file. And we create it by right-clicking the project, selecting New, then TestNG. Provider name can be any name, but it is a convention to name the XML file as testng.xml. If you do not have TestNG as an option after selecting New, then you can create it from scratch by finding a template, then copy and pasting the information from the template. For example, you can right-click the project, select New, then File. Name the file, how about TestNG_classes. Make sure to add .xml as the extension. Then you paste the default information. Now we have TestNG XML. To run both classes, we start by adding a suite name. And let's make the name Annotations. Now we add the tags. A suite contains one or more tests. So the first tag is test. Name is a required attribute. And the name for this test, how about we call it Run Class Annotations. A test contains one or more classes. Therefore, the next tag is classes. Now we must add each class by writing class. The class name, it starts with the package name, which is demo TestNG. Then the class name. The IntelliSense shows us two classes, configuration annotations _1 _ date pickers, configuration annotations _2 list box. Let's select date pickers. Let's also add one more class for demo TestNG dot and select the second one. Now we have both classes. Let's run to see if it shows us all four methods for both classes. And it looks like it print the correct information because we see all four methods. Test method 1, test method 2, test method 3, and test method 4. Notice we see a print statement for number 3. Before class, dates pickers, and after class, dates pickers. Also, number 3, before class, list box, and after class, list box. They print before and after each class. For number 4, we see execute before each test method preceding the test method and execute each test method following each test method. In addition to executing each class, we can also execute a method, a particular method. We can pick and choose which method to execute in the class. For example, let me copy and paste this XML. Then I'm going to rename it to methods. Update the name from run class annotations to run methods. A class contains one or more methods. Therefore, we write methods. That's the next tag. And within that method, we can include each method we want to execute by using include as the tag. The name is test_1 bootstrap date picker. And let me verify that the name is correct. Yes, bootstrap date picker. I'm going to not include test 2. So with this setup, test 2 will not execute, but test 3 and 4 will execute because we have the complete class. So in the console, we should see test 1, 3, and 4. Yes, we see test method 1, no test 2, but we see test method 3 and test method 4. There is another feature the TestNG offers. And let me copy and paste this tag and change test 1 to test 2 jQuery date picker. So with that new feature, we can exclude a test. Now test method 1 will not execute. Let's run. As expected, we do not see test 1, but the console shows us test method 2, test method 3, and test method 4. So far, we have seen the test annotation, before method, after method, before class, and after class. Now, let's look at before test, after test, before suite, and after suite. The XML file gives us a clue on how they would execute. At the top level, we have suite. So that's the before suite annotation. At the bottom, we see suite, and that's the after suite annotation. The next level is test. If we wanted to, we could add more test tags. Each test tag shows us the before test and after test annotations on how they would execute. For this tutorial, let's only keep one test tag pair. Let's go back to class 2 and continue with the annotations. With this annotation, the next one is at before test, public void, before test. And I'm going to add a print statement with 1-2 spaces, and it execute before each test. Next is the after test annotation. Let me change the name from before test to after test, and it execute after each test. The next pair is before suite and after suite. So let me add those annotations. Before suite, public void, before suite. The test annotation is execute before the suite. I'm going to also copy this information and paste, then change before suite to after suite. Also the method name after suite. Finally, the print statement. Now let's run and see what the console shows us. I'm going to execute the classes XML file because it have all 4 methods. In the console, we see 1, 2, 3 for the suite, test, and class at the top. At the bottom, we see class, test, and suite. In the middle, we see each test method, the before methods, and the after methods. Also, the before class and after class. So the console shows us all of the annotations that we expect. There is one last concept for the configuration annotations that I want to show you, and that is the before group and after group annotations. The purpose of these 2 annotations is to execute before and after any test that is mentioned in a particular group. So for that setup, we have to add the test methods to a group. You know how automation is good for executing smoke tests and regression tests? Let's create those test types. In class 1, for test 1, we write groups equals smoke. For test 2, we write groups equals. We can also include curly braces, then double quotes. For this, it will be regression. That's all we need to add a test to a group. If you wanted to, you could add one test to more than one group. For example, we have regression. I'm going to also include end to end, which is ETE for short. In class 2, the test annotations is at the class level. So every test method will be in the same group. How about groups equal smoke? Now we have added the test to a group. And at this point, we write the annotations before group and after group. So it's the same concept, at, before, group. However, this time we add the groups. The groups are regression and smoke. The print statements will come after I name the method, which is public void before groups. Let's include a print statement that says execute before group. Copy this information, then paste it. Change before to after for the annotation, the method name, and the print statement. Now we are going to use an XML file, but I'm going to copy the XML file from the classes file because it includes all of the methods. Paste, then rename it to groups. At this point, we need to include a tag inside of the test tag, and that test tag will be called groups. Inside the groups tag, we add run. I'm going to also rename the test name to run group annotations. Now, inside of the run tag, we decide what group we want to run. Include the regression. Just like the methods, we can exclude a group. Let's include smoke. You know what? If I do not plan to run a method or run a group, I prefer to remove it. Let's remove regression and only run smoke. Now, let's run. The console should show 3 test methods. In the console, we see test method 1, test method 3, and test method 4. The group print statements print before the test method, and it print after the test method. That's it for TestNG annotations. Next, we will write our first test using TestNG and Selenium. The advantage of TestNG is to test our AUT, application under test. However, Selenium is used to automate our test. In this tutorial, we are going to use TestNG and Selenium to create our first automation test. The AUT is called Selenium Playground. I will show you two pairs of configuration annotations: before class, after class, and before method, after method. I'll also show you the test annotation and the benefits of using a method called priority. Priority helps us to prioritize each test when one class has more than one test. All of the source code is located on GitHub. Let us start by creating our class by right-clicking the package demo TestNG, new Java class. The name is first underscore automated underscore test. Let's hide this project, then write WebDriver. The purpose of WebDriver is to control our browser, which is Chrome. Import WebDriver. Now we set up our class by writing @before class, then public void set up. Now we write WebDriver manager. WebDriver manager automatically manages our driver, which is Chrome driver. For us to set up, let's go ahead and create an instance of Chrome driver by writing driver equals new Chrome driver. At this point, we can maximize the window in our browser by writing driver.manage.window.maximize. Now we load the application by writing driver.get. We must pass in the URL. So let's go back to the AUT, copy the URL, then paste the URL. In the previous sessions, we covered 5 configuration annotations. And those 5 configuration annotations were before class, after class, before method, after method, before groups, after groups, before suite, after suite, and before test, after test. By default, I prefer to use the before class configuration annotation to set up our WebDriver and to create an instance of the driver. I use before class because it executes the first test method in the class. The after class annotation executes the last test method in the class. Most of the times, depending on the application, I take a different approach on the page object model design pattern. For the page object model design pattern, I implement 2 pairs of annotations. I use the before class, after class, before method, after method annotations. The before class annotation, I use it to set up WebDriver, then create an instance of the driver, just like in this example for setting up our test. However, when it comes to loading the application, driver.get, I use the before method annotation. In the after method annotation, I take a screenshot of every test that fails. We are finished setting up the class. For the after class annotation, it tears down our class by writing after class, public void tear down. Then we write driver.quit. Driver.quit closes all of the browser windows and quit the driver. Now we are ready for our test. There will be 2 test scripts. The first test comes to this home page. Then click Table, Sort, and Search. After clicking this link, it will search for a name like 𝒆𝒃𝒏𝒆𝒔. The result should return only one name, position, office, age, start date, and salary. The second test script will click this bootstrap dates picker hyperlink. The test will enter a birthday like January the 1st, 2001. For the test, let's start by adding our test annotation with the name like test table sort. Yeah, sort and search. Let's inspect the table sort and search hyperlink. And let's see what it returns us in the DOM. We see an A attribute, an A tag with two attributes. The attributes are href and class. We do not see an ID attribute, but that's okay because we're dealing with a hyperlink. So we're going to use the link text method from Selenium to find this element. So all we need is this text of table sort and search for the link. Copy the text. Now I'm going to find the element by writing driver.findElement by link text. Then paste in the value. And for links, we click. Therefore, I will use the click method from Selenium. That's it for the first step. For the second step, let's go back to the AUT. Click table sort and search. Now let's inspect the search field. We see it has an ID, no ID attribute, but it has a type attribute in the input tag. So since it does not have an ID attribute, let's go up to the ancestor to find the ID attribute. And the ancestor has a value of example underscore filter for the ID attribute. We're going to find the elements in this DOM. Control F. Now we're going to write 2// div for the tag name, 2 square brackets at ID value equal 2 single quotes. Now we paste the value. Bingo. The yellow highlights background indicates we have found the element. We have found the ancestor. Now let's find the search field box. 2// input is the tag name. 2 square brackets at the attribute is type equal 2 single quotes, and we type in the word search. We have found the element because of the yellow highlight background. Now, for Selenium, we always find the element before performing an action on the element. To find the element, we write driver.findElement by XPath. And I copied the value from the DOM, so I paste it. And since this is very long, and I want you to be able to see the complete value, I'm going to put it on the next line. For the search box, to perform an action, we have to send keys. And send keys is how we enter a value. The value will be a.rainbows. Bingo. That's the action for send keys. Before running this test, let's comment out driver.quit. I'm commenting out driver.quit because Selenium executes so fast that we may not see the value get entered and the results of a.rainbows in the AUT. Bingo. AUT only shows one result for a.rainbows. That's right. Okay, and the application shows that it passed. The second test script, we start with the annotation test with the name like test bootstrap date picker. On the home page, let's inspect the hyperlink of boot date picker. And just like the other hyperlink, we only need the text, so we can use the link text Selenium method. I copied the value. Now I'm about to find the value, or find the element, by writing driver.findElement by link text, paste the value. And for the links, we click. Bingo. Next, we enter the date of birth after clicking the link. So let's go back to the AUT. Click the link. Now we're going to inspect the birthday field. It shows a value of birthday for the ID attribute. Let's check if it is unique. And within this search box at the bottom, I will use CSS selector. The hashtag is a shortcut for the ID attribute. Put in birthday and we see the yellow background. So birthday is unique. Plus we see the results show 1 of 1. Therefore, let's go back to the IDE and find the element by writing driver.findElement by. We have the option of using any one of these 8 Selenium locators. We can use CSS selector and put in the value with hashtag birthday. However, ID is my #1 locator whenever I'm trying to find a value. So I'm going to use ID with the value of birthday. And for birthday, we're going to send keys. The value we are going to send is 𝒃𝒐𝒏𝒆𝒔 Now, let's run. And when I mentioned my preferred choice of #1 is ID, some people use CSS selector and others use XPath. Either way, it's okay. It just normally in the DOM, ID should be unique. So that's why I use ID. In the AUT, we see the value showing 𝒃𝒐𝒏𝒆𝒔 So that's working correctly. We see how each test passed, running them one by one. Now let's see how they operate when running them together as a class. Therefore, each test will run together in the class, back to back. Both tests will run. Now I'm going to execute the class first automated test. Bootstrap date pickers. In the IDE, we see 1 test passed and 1 test failed. Test bootstrap date picker passed, but test table sort and search failed. Let's investigate the failure and see why it failed. We see no such element exception. The method link text could not find test table sort and search. Let's go back to the bootstrap date picker page. So in other words, it failed because it could not find the link. If we come back to the execution, we are on the bootstrap date pickers demo page and it cannot click the link table sort and search. However, there are at least 2 ways to solve this issue. We can click the table menu link like I just did in this here, click table, then click table sort and search, or we can use before method, after method in replace of the before class, after class annotations. I will show you both ways because we see we're on this page. So let's first inspect table. And by inspecting table, we see it has a P tag. Let's expand the P tag. Now we see table. And it does not have an ID attribute. So let's scroll up to to find one of the ancestors with an ID attribute. Bingo. The div tag has an ID value of _next. Now let's find the element by writing 2 / div, opening closing square brackets, at ID equal 2 single quotes. We found the element. Now let's find table. 2 /, the p tag, closing and opening closing square brackets, text. Text is letting this search engine know that we are going to find the element using the text, and the text is table. Bingo. We found the element, table. Now let's copy the value, go back to the IDE, and before we click table, sort, and search, we're going to click table. Therefore, before this line, let's write driver.findElement by XPath and paste in the value, and that is to click. Now, this statement, click the table link menu item. The next line, we'll click the link table, sort, and search. This table, sort, and search page will work on the home page, and it will work on the Bootstrap date picker page. It works because it's the same link text value of table, sort, and search. Now, let's run. This time, we should see both tests pass. We see the value 𝒃𝒚 correctly, and we see both tests pass. Test Bootstrap date picker, test table, sort, and search. Now, let's use the second way by changing before class to before method, after class to after method. Imports both annotations. Now let's comment out this line here to click the table menu element. We do not need the table menu element to be clicked because the before method and after method will execute and load the application before each method. Therefore, it will always go back to the home page. Now, let's run. This is the first execution for Bootstrap date picker. It's been loading another page for table, sort, and search. And the ID value or the ID shows both tests pass. Good. So that's why I mentioned earlier that depending on the application in my page object model design pattern, I use the before method annotation for loading the application, but still set up WebDriver in the before class annotation. Did you notice in the class, I wrote test, table, sort, and search first before test Bootstrap date picker. However, in the run window, test Bootstrap date picker executed before test table, sort, and search. It executed first because TestNG executes the method names in ascending order, and test Bootstrap date picker is before test table, sort, and search. It's okay because TestNG also provides the priority attribute to help us determine the test execution order. For our test table, sort, and search method, let's write priority equals 1 after the test annotation. For test Bootstrap date picker, let's write priority equals 2. We can also use a negative number because the execution executes the lowest integer first. It's the first one to be scheduled to execute. Now, let's run to complete class. We should see both tests pass with test table sort and search as the first execution. Number 1, table sort and search. Number 2, bootstrap date pickers. In the IDE, both tests pass. Test table sort and search executed first because it had that priority of 1. If I hover priority, control and click, we see it has a default of 0. This class is the test annotation class. And if you want to see a list of all the methods for this test annotation, you can open a project, and here we see all of the methods that can be used for the test annotation. We see priority int. It's int because it's an integer. In the previous tutorial, we used groups for the configuration annotations before groups and after groups. Here is the test annotation and the 5 pairs of configuration annotations. Before suite, after suite. Before test, after test. Before groups, after groups. Before class, after class. Before method, after method. Configuration annotations that start with before are considered preconditions because they help set up the test. The condition is the test annotation because it has steps. When it comes to us automating the application, the configuration annotations that start with after are considered post conditions because they finish when the condition is complete. The preconditions are at the top, then the condition, and the post conditions at the bottom. However, we only use in this tutorial before class, before method, test, after method, and after class. That's it for TestNG in our first test automation. Next, we're going to use and look at the TestNG assertions to verify our application actually passed or failed. A TestNG assertion verifies if the test passed or if the test failed. We have the option of using hard assertions and soft assertions. The difference happens after a failure. A hard assert stops execution after a failure, but a soft assert continues execution after a failure. It is best to use a hard assert if our test only has one result to verify in the same annotation. However, if our test has more than one result to verify in the same annotation, then it is best to use a soft assert. There are many assertions for TestNG. However, most of the methods are overloaded versions of assert true, assert false, assert same, assert not same, assert not null, and assert equals. Assert true verifies that a condition is true. Assert false verifies a condition is false. Assert same verifies that two objects refer to the same object. Assert not same verifies that two objects do not refer to the same object. Assert not null verifies that an object is not null. Assert equal verifies that the actual results and the expected results are equal. When it comes to the assertion classes, TestNG offers org.testng.assert and org.testng.assert JUnit. Most people use the first class, org.testng.assert. The second class was added as a guarantee to keep all assertions for anyone migrating from JUnit to TestNG. When it comes to the differences between those classes, one of the differences come to the syntax. Their parameters are available in reverse order. For example, the assert equals method for the assert class has actual results, then expected results, followed by an optional string message. The assert JUnit class has the string message followed by expected results, then actual results. Let's go to the IDE and take a look at the TestNG library. And you will see what I'm talking about in the TestNG library. In the TestNG library, we see assert and assert JUnit. In the assert class, we see some of those same overloaded methods. In the assert JUnit class, it also has some of those same overloaded methods. Also in this library, asserts directory, we see the soft assert class. For the first test, we're going to click this demo, checkbox demo link. Find the checkbox, then click the checkbox. After clicking the checkbox, we will assert the message has success. The second test, on the home page, we will click the radio buttons demo. And for this group, radio buttons demo section, we're going to click the gender and age group. Gender, how about other? Age group, how about 5 to 15? After clicking those radio buttons, the next step is to click the Get Values button. And with clicking that Get Values button, we will assert in our test the gender and age group. And let's see if it fails or if it passes. Now, starting with our test, let's create a class by right-clicking Demo, TestNG, New, Java class. The name is Assertions Test. Next, we're going to write WebDriver. And we're also going to import WebDriver. Now it's time to set up our test by writing at before method, public void, set up. Now we're going to write WebDriver manager to set up Chrome driver. At this point, we will create an instance of Chrome driver by writing driver equals new Chrome driver. Maximize the window with driver.manage.window.maximize. At this point, we will load the AUT with driver.get. Go back to the AUT to copy the URL. Paste the URL. Now we are finished setting up the test. To start the test, we're going to write add test, public void test single checkbox. Now, let's go to the AUT and start some inspections. Let's start with inspecting the checkbox demo link. We see it has a text of checkbox demo. Go back to the IDE and find the link by writing driver.findElement by link text. Paste the value of checkbox demo. And for the link, we perform an action of click. Now, let's go back to the AUT. Click this checkbox demo link and we're going to inspect the checkbox. And we see it has an ID value of is age selected. Copy that value, go back to the IDE, and write driver.findElement by ID. Paste the value, and we click the checkbox. At this point, we need the message. So I'm going to inspect the message. It has an ID value of txt age. Copy that value. Now we're going to find it by writing driver.findElement by ID, pasting the value. Now, at this point, we have the message. We have found the message, and we will use the getText method to get the message, and it will return a string. Therefore, we assign it to a string with the name called actual message. Okay. The next step is to verify if the test passed or if the test failed. Let's start by writing a hard assert with assert dot, and we see the overloaded methods. We also can see the overloaded methods if I write assert JUnit dot. It has some of those same methods. Recall TestNG added this distribution for people migrating from JUnit. Our focus would be assert. So let's use assert true and make sure the actual message contains success. If it does not contain success, then the assertion will display message does not contain success. The message is not required and will only print if the assertion failed. Let's run. It passed. Personally, I believe it is a good practice to make your test fail on purpose. You want to see how your tests respond to a failure. So on my projects, I make the test fail on purpose by updating something like changing success to test. Then I will run again, just to get an idea on what will happen in case of a failure and how it looks when it fails. We see it failed and scroll down, and now we see the assertion message. It says message does not contain success. Expected true, but found false. Cool. So now I'm going to change this back to success. For the next test, test annotation, it is public void, and we will test radio buttons with an S. Go back to the home page, inspect radio buttons demo, and we see the text is radio buttons demo. Okay, we will use Selenium's link text method to find this link and click the link. In the group radio buttons demo section, let's inspect other, the radio button. And we see it does not have an ID value, but it has a value attribute with the value of other. Let's find this element by writing 2 forward slashes, input, which is the tag name, 2 square brackets, at value, which is the attribute name, equals to the value other. We found the element, and the indicator is showing a yellow background. So now let's go ahead and click the link on the home page, and we're going to click the gender radio button of other. So let's write driver.findElement by link text. The link text is, I think it was radio, let me go back and copy it. Radio buttons demo with an S. The method is click. Now we're going to click the gender, and that is driver.findElement by XPath, paste the value, click. At this point, let's go back and inspect the age group radio button, 5 to 15. We see it has a value of 5 to 15. So I will replace other with that value. And as expected, it found the element. So I'm going to copy the value, go back to the IDE, and write driver.findElement by XPath, paste the value, and also click. Now, next is the get the values button. And by the get values button, we will also click. Let me inspect. It does not have an ID value, but we see the button tag name, type attribute, and class attribute. So let's find this element with text by first starting with 2 forward slashes, button, the tag name, square brackets, text, parenthesis, equals, single quotes, paste the value. There it is. Copy and go back to the IDE. And going back to the IDE, we're going to first find it, driver.findElement by XPath, paste the value. And we're going to click. Now, we're going to get the values after clicking get values. And the first one we're going to get is the gender. We see it has a span tag with one attribute, and that attribute is called class. Normally, I would not use the class attribute to find the value, but for this demo, let's go ahead and find it using CSS selector. And the shortcut for the class attribute is dot. And the name was gender button. Once again, we see the yellow background highlighted, which shows that we have found the element. So I'm going to copy the value, go back to the IDE, and this time I'm going to write driver.findElement by CSS selector, then paste in the value. The method is get text. And since it returns a string, we're going to assign it to a string called actual gender. And I'm going to place it on 2 different lines because it's pretty long, that one statement. Now, we have found, and we are going to get the text of gender. Next is the age group. Go back and inspect age group. It has a class attribute with the name of group radio button. So all I'm going to do is replace gender button with group radio button, and we have found that element. Copy the value, come back and write string actual age group, if I spell it right, and find it by writing driver.findElement by CSS selector, paste the value. Get text is the method. Bingo. Now we are finished setting up everything. When it comes to assertions, I will first demo hard assert, then demo soft assert. For hard assert, we write assert dot. This time, let's use assert equals. I want to make it fail on purpose. Therefore, actual age group, actual gender is what we click in the application under test, but the expected value is male. Now, since we're going to make it fail on purpose, this message would show up. Actual gender is not correct. We're clicking other, but expect male. For the next assertion, we write assert true. And it will see if the actual age group contains, how about 34? And when it comes to this part, looking at it right now, we know both statements will fail. And when this fails, we're going to see a message of actual age group is not correct. Okay, so both statements will fail. Now let's check and see. Let's run. The statement failed. However, in the console, we see only one assertion error. Actual gender is not correct. Expected male, but found other. Notice the second assertion is not available. That's because we use a hard assertion, and hard assertion stops executing our test script immediately after the failure. Okay, now I would have changed from a hard assert to a soft assert, and watch what happens. At the top, let's declare soft assert with any reference name such as soft assert equals new soft assert. The soft assert class extends the assertion class. As a result, we have access to all of the overloaded methods just like the assert class. Let's investigate by pressing Control, hovering the class, and clicking the class. And let me minimize these methods right quick. And we see in the soft assert class, there's only 3 methods. The do assert class, the do assert method is protected, and we have overloaded methods of assert all. That's it. I'm going to scroll up, and we see that it has a constructor of soft assert, and it extends assertion. If I click assertion, we see those same overloaded methods of assert true. We see assert false, and it has more overloaded methods like assert equals. Now, we're going to go back to our test script. Let's continue testing. I'm going to replace assert with soft assert in both places. And this time, I'm going to run again, and you will see the difference between hard assert and soft assert. You know what? This time it's going to pass. And that's one thing that we must always remember to do. And I will show you. We know it should fail, but watch what happens. Because I did not add one key method. You see it shows a pass, and we know it did not pass. If I scroll, we do not see no assertions. That's because we must always remember to add soft assert all at the end with an optional message of test soft assert. Now watch what happens when I run again. it failed. So if you use soft assert, remember to always use assert all at the end. Now that it failed, let's check the console. We see both assertion messages. First, we see actual gender is not correct. Expected male, but found other. And we also see the other assertion message, which is age group is not correct. And if someone wonders why I add the \n at the back and front, because in my opinion, it's good for readability. You see how this is all on one line, but this is on two separate lines. That's why I like to put the insertion, but it shows both messages because its soft assert continues execution after a failure. Now, we also see that message of test soft assert. Let me go back now, and I'm going to remove this message because it's optional. And I'm going to run again and watch how it reads different in the console. Let's run. We see it failed, scrolling, and we see both assertion messages. Actual gender is not correct, expected male, but found other. Actual age group is not correct, expected true, but found false. Let's do one more thing, and let's make the second assertion pass by changing 34 to 15. Now, let's run again. Okay, the test still failed because gender is not male, it is other. But I wanted you to see how it's still executed and continued, and it shows that the second assertion is not available because it passed since the age group contains 15. So as a recap, an assertion statement verifies if a test passed or if the test failed. There is a difference between hard assert and soft assert. A hard assert stops execution after a failure, then move on to the next annotation. If there is another annotation, it does not matter if the next annotation is a test annotation or a configuration annotation. It's going to move to the next statement line. A soft assertion continues execution after a failure. It was designed to keep executing our test when a verification step fails. Now, when you're looking at this diagram, you see how there are many conditions on the left side, and we see soft assert dot assert all on the right side. There are many overloaded methods in the assert class. Now, with this part, the diagram, it shows a few assertion methods on the left. And when it comes to that, the assertions are pointing to the assert all method because they indicate an assertion error gets stored into the assert all method. As a result, we place the assert all method at the end of our test every time. And I showed how if we don't place it at the end, it would pass every time. It is best to use a hard assert if you are verifying only one result, and a soft assert if you are verifying more than one result. That's it for soft assertions, hard assertions. Next, we will parameterize our test with TestNG and Selenium. And thanks for watching. In our automation code, parameterization starts with the parameter tag and parameters annotation. The purpose of a parameter tag is to define the name and value of a parameter. The purpose of a parameter's annotation is to specify how to pass parameters and which parameters to pass to the method. Therefore, in our project, it requires an XML file for the parameter tag and a Java class for the parameters annotation. The application under test will be Selenium Playground from LambdaTest. Let's walk through the test script. First step is to click File Download. Next step would enter data like just a test. Then click the Generate File button. The last step is to click Download. All of the code will be on GitHub. Now we're going to the IDE to create our class. And we do that by right-clicking Demo TestNG, New Java class. The name will be Parameterize Test. Let's add one more file for TestNG by right-clicking the project Tutorials TestNG, New TestNG. The name will be TestNG underscore parameters.xml. In the Java class, we start by controlling the browser with WebDriver. We have to also import the WebDriver. Set up the test with before class. Public void setup is the method name. Let's also do the test part with the test method beginning with the test annotation. Public void test file download. The last part we're going to set up is the teardown method. And for the teardown method, we're going to have the after class annotation, public void teardown is the method name. And we write driver.quit. How about we add some steps? For the setup method, let's write step 1, load the AUT. For the test method, let's write step 2. We're going to click the file download link. Step 3, enter data. Step 4, that's going to click the generate file button. Last but not least, step 5. And that will click the download link. After clicking the download link, we're going to open the file. Now it's time for the XML file. Let's name the suite Parameters Suite. Bingo. We have the option of placing the parameter tag at the suite level or test level. Starting with the suite, let's write parameter. Name is URL. Let's go back to the AUT to get the URL. Copy, then paste in the value between the double quotes. Now we have the URL value. For this tutorial, let's create 3 separate parameterizations. We're going to pretend the values are test results. The test results will be pass, fail, and skip. So we need 3 pairs of test tags. The next test tag, we're going to write the name of, how about pass, parameters test. Next, we're going to just copy these 2 tags and paste them, and then rename pass to failed. I'm gonna go ahead and make some room at the bottom just in case I need to scroll up or scroll down. I'm going to paste another set of test tags and rename that to skip parameters test tags. Recall the parameter tag can be within the suites or test. We must have a name attribute and a value attribute for the parameter tag. So for the test parameter, we're going to write the name of test result with a value of pass. Within the classes tag, I'm going to have the class tag, and that's where we're going to add the class. But it starts with the package name of demo TestNG followed by the class name. Now that we have the first test complete, I'm going to copy this information and paste it for the next two tests. So far, we have two parameter names. At the suite level, we have the name of URL. At the test level, we have a name of test result. If we add the same parameter name with different values at the suite and test, then the test will override the suite. For example, if URL was also at the test level with a different value, then the automation code will use the value at the test level. The test will override the suite because the test is closer to the class level. That's the main reason why we are going to use different values for suites and tests, because I want to show you both ways. Now, if I decide to place it at the suite level, I'm doing that because all classes need the same value. The test need the same value of URL for pass parameters, fail parameters, and skip parameters. And since they all need the same value of URL, that's why I placed it at the suite level. If they need a unique value, I place it at the test level. So kind of a recap to explain what I just mentioned. If all classes need the same value, like URL, I add the parameter tag at the suite level. If the classes need a unique value, then I use the parameter tag at the test level. The parameter name of test result will have a different value for each test. So when I copy parameter, classes, and class and paste it into the second test, all I do is change pass to failed. And the same process for the third test. When I paste it, I'm going to change it from pass to skip. Okay, so the values for parameters are always string, and we see how they're located within double quotes. Let's add one more parameter at the suite level. So let me go ahead and add another tag parameter and name this task with the value of, how about download file. Now by default, they give us double quotes, but we can add a single quote or double quotes. So let me take this chance to replace double quotes with single quotes to show you it does not matter if it's double or single. That's all we need for parameterization for the TestNG XML file. For the class file, we add the parameters annotation above configuration annotation or below configuration annotation. It's the same for the test annotation. The parameters annotation can be above or below the test annotation. So for the configuration annotation of before class, I'm going to add the parameters annotation above it. For the test annotation, I'm going to add it below, just to demo both ways. The objective is to pass in the URL value from the XML file to the Java class. In the parameters annotation, we need to write the same parameter name from the XML file. So therefore, we see that the name is URL in all caps. In the parameters annotation, I'm going to also write it in all caps. Let me take this back to the top. Now, since the URL value is a string in the XML file, in the class file, we must add it as a string in the method parameters. And notice how the method requires a parameter, but it can be any name. However, I always write the same name with lowercase letters. So we see it in uppercase letters for the annotation. But in the method parameter, I made it lowercase letters. That's a way for me to tell a difference. Parameters in the annotation are different from parameters in the test method. Parameters in the annotation are a list of names to be looked up in the XML file. Parameters in the method receive the values from the XML file. So let's go back to the XML file and you see the name and the value. The annotation has the name. The method parameters has the value. Therefore, one of them gets the parameter name and the other one gets the parameter value from the XML. At this point, we can go ahead and write the Selenium automation code to set up the test. In the method, we write WebDriver manager.ChromeDriver.setup. Now we create an instance by writing driver equals new Chrome driver. Maximize the window with driver.manage.window.maximize. Last step is to load the AUT by writing driver.get. Now we pass in the URL. Bingo. We are now finished setting up the test. If I run this test right now, then we should see 3 separate executions. Let's run. In the run window, we should see pass parameters, fail parameters, and skip parameters. And I made a mistake because we should always execute from the TestNG XML file and not the Java class, because we see how it returned an error. So let me do that one more time and run. Okay, so the run window shows pass parameters test with a green check mark, fail parameters test with a green check mark, and skip parameters test with a green check mark. Let's complete our Selenium code. In the test, we click the file download link. So let me inspect file download. And we see it has a text of file download. So going back to the IDE, I'm going to write driver.findElement by link text, paste in the value with an action of click. That's finished. So let me remove the comment. Next step is to enter data. Go back to the application, click file download, and I'm going to inspect the text area of enter data, and it has an ID value of text box. Copy, go back to the IDE, and now I'm going to write driver.findElement by ID. Then paste in the value, and to enter data, we use a Selenium method of send keys to enter the data. Okay, for the setup method, we passed in one value. For this test method, let's pass in two parameters. And those parameters will be task and test result. Now, going back to the Java class, we're going to pass in the parameters from the XML file. Tasks, let me go back right quick. Task is located at the suite level, and test result is located at the test level. So when it comes to the Java class, we pass in the data with the same concept that we did for the setup method. For the parameters annotation, we write parentheses, the curly brackets, and double quotes. Within the double quotes, we write task. Then we write test result. Then the method parameters. And the method parameters are, no, I see we have an issue. And the issue is because I placed this at the wrong spot, and I apologize. Parameters is where I belong. Now that we have that, at the method parameters, we're going to add string task and string test result. The value for task is download file. So for send keys, we write task. How about the complete statement be download file execution? Then we pass in the second value of pass, fail, or skip. Therefore, we add a plus symbol. And let me skip a line. Execution, colon, space, and test result will be what we pass in as the second value. That's it for parameterization. The remaining automation code is using Selenium in Java to click the file, generate file button, and to click the download file, click the download link. So for the remaining part, let's go ahead and inspect generate file. And it has an ID value of create. I'm going to copy the value, and remember to delete this comment because it's not needed anymore. And to click the generate file button, I'm going to write driver.findElement by ID. Paste in the value to click. The next part we need is to click the download link. So let me go back to the AUT. Enter some data again, just the test. Click the file, generate file button, and now we see the download link. Let me inspect download link, and it has an ID value of link -to download. Copy the value, and for step 5, I'm going to write driver.findElement by ID, paste in the value, Selenium method of click. Now we are ready to see each parameterization after downloading the file. Let's add a sleep statement right quick so we can see the data in the application. So in the turn down method, I'm going to write thread.sleep and pass in 3000, which is 3 seconds. And I'm going to add the exception. Now, let's run. I made a mistake again, and I apologize. I keep running from the Java class when we should run from the XML file. Download file execution pass. Download file execution failed. Download file execution skip. Okay, all 3 files were downloaded. Let's go to Windows Explorer. And here's my download. Okay, so let me open the first file, increase the font, and it shows download file execution pass. Click the second one and increase the font, and it shows download file execution failed. Lambda info 2 shows download file execution skip, like what we expect. To recap, the XML file defines the name and value of a parameter when using the parameters tag. If we add the same parameter name at the suite level and test level, then the test will override the suite. When it comes to the class, the parameters annotation identifies how to pass parameters and which parameters to pass to the method. It's the difference between parameters in the annotation and method. Parameters in the annotation are a list of parameters named from the XML file, and parameters in the method receive the values from the XML file. Next, that session will deal with showing you how to capture a screenshot for test results that failed. And I will see you in the next session. Thank you. Taking a screenshot is great for automation because when the test failed, we can analyze the execution flow to determine 2 things. Where did the test fail and why did the test fail? First, I will demo how to take a screenshot of each test, then demo how to take a screenshot of only a test that failed. All of the code will be on GitHub. Let's start by walking through the application under test, Selenium Playground from LambdaTest. The test includes clicking simple form demo. After clicking this link, the next step is to enter a message like LambdaTest is awesome. After entering that message, we click the Get Check Value button. Notice under your message, another message shows up, which is the same information. LambdaTest is awesome. The screenshot will happen when we on purpose make the actual value and the expected value not match. So let me copy the URL. Then go to our IDE. In the IDE, we go to the package demo TestNG, right click, new Java class, and the class will be called Take Failed Screenshots. Bingo. After adding the new class, at this point, we control the browser by writing WebDriver, and we have to import WebDriver. After importing WebDriver, the next step is to set up our class with the before method annotation from TestNG. The method name will be public void setup. Now we're going to set up Chrome driver with WebDriver manager.ChromeDriver.setup. At this point, we must create an instance of Chrome driver with driver equals new Chrome driver. Also, we have the option of maximizing the window with driver.manage.window.maximize. And we're going to load the AUT with driver.get and paste in the URL. Now, when it comes to the take screenshot, we're going to add that to the after method annotation. when we finish setting up, not setting up, but when we finish our test, which is public void test simple form demo. First step is to click the link on the home page. So we write driver.findElement by link text, and we're going to paste in the value after we make this here click method to perform the action. So in the UI, let's right click simple form demo just to make sure in the DOM it is simple form demo, because sometimes what I noticed in the DOM, in some applications, it could be an extra space before the word, after the word. So that's why sometimes I copy the value even though I have an idea what the value is. Click the link. Now we're going to inspect the next element, which is the text box for enter your message. And we see it has an ID value of user message. And let's see what it shows us by putting the value at the bottom using CSS selector. The hashtag is a shortcut for ID. And we see there is not a unique element using this value. It shows 1 of 3. That means there are 3 elements with that same value. Let's find a unique value. We see enter message above the text box. Therefore, we can locate enter message, then find the input box. Let's use XPath. Inspect enter message, and it shows a P tag name and 1 attribute of class. So let's write in the value box at the bottom 2 forward slashes, P for the tag name, the square brackets opening and closing, followed by text, opening closing parentheses, equal, 2 single quotes. Now let's enter the text of enter message. Bingo. We found the element because the DOM highlight the element in yellow. The input element box is right below the enter message. And we also see how they both are children under the UL parent tag. So to find the enter message text box, let's write 2 forward slashes, following 2 colons, then, no, following sibling, because there are siblings. Now we write the 2 colons, input, bingo. We found the checkbox. No, we found the text box because we see it highlighted yellow. So let me copy this value and go back to the IDE. And for the link text, it was simple form demo. The first statement is finished for clicking the link. For the second statement, we find the element by writing driver.findElement by XPath. Paste in the value, and it is a long value. So for send keys, let's put that on the next line so it enters the value of LambdaTest is awesome. Let's add 3 exclamation points. Next step is to click the button. So let's go back and inspect the button called Get Checked Value. It has an ID value of show input. So I'm going to copy the ID value, go back to the IDE, and write driver.findElement by ID, then paste in the value. The action is click from Selenium. At this point, we will verify if the message is correct or not correct. So let's go to the application one more time and enter a value like LambdaTest is awesome, some exclamation points. Then click the button. After clicking the button, we see the message and it shows LambdaTest is awesome for your message. Let's inspect the message. And it shows an ID value of message. So I'm going to copy the ID value, come back to the IDE, then write driver.findElement by ID, then paste in the value. And this time we use the getText method from Selenium. Then assign the value to string. I'm going to put it on two separate lines. String actual message equals. I'm putting them on separate lines so we can try to see everything in this one screen. This statement returns the message from the AUT. Now let's verify the message is not correct, or if it is correct, using the assert from TestNG. Assert that it equals actual message, and we're going to put the expected message of LambdaTest is awesome with 3 exclamation points. Now, if the actual message and expected message do not match, the console will show message is not LambdaTest is awesome. Bingo. So I'm going to also bring this over some more too, just to make sure we have enough room on the screen. Let's run and see if the test works. Yes, the test passed. Let's start by taking a screenshot of each test. So now we are at the point where we can add the configuration annotation of after method. Bingo. The name will be take screenshots for failures. We cast our driver to an interface called take screenshot. After casting the driver, we assign it to take screenshot with the reference of, how about we name it screenshot? Bingo. Now, the reference screenshot provides access to the get screenshot as method. Get screenshot as performs the action of capturing the screenshots and storing the screenshot in a location. The method get screenshot as takes a parameter of interface called output type. And output type can be base 64, bytes, or file. We need the file so we can save the screenshot as a file. When we capture the screenshot, it will become our source. Therefore, we write file source. And we must also import file. Now, after importing file, next is to move the file to a destination. File is a class that represents a file or it represents a path directory. let's create our directory, then come back and write our directory. In the project tutorial TestNG, we right click, new directory. Name is resources. Let's also create a subdirectory by right clicking resources, new directory. The subdirectory name is screenshots. Bingo. Now, we have created the directory. Now for the destination directory statement, we're gonna write new file system dot get property. Within the parentheses, we make the double quotes and then write user.dir. Let's make room. On the next line, we're going to write the directory name of resources, subdirectory of screenshots. Let's name the file test simple form demo. How about _pass.png? Because this will pass when it runs. User directory is the working directory. Resources, screenshots are the directory folder names with test simple form demo pass as the file name. Last step is to handle the screenshots by copying the source from the source to the destination. Therefore, we write file handler dot copy. Let's also import file handler. And it looks like it's already been imported. And if it has, it's the wrong import statement. So let's remove file handler if you imported it accidentally like I did. Import file handler, and we're going to copy from the source to the destination. Do you see the red line under copy? That means we must add an exception or surround file handler with a try-catch block. So when I hover the red line, we see add exception to method signature. But we're going to click more actions to select surround with try-catch. The try-catch block will try file handler, and if there is an exception, then it will catch the exception. This is all the code we need to take a screenshot of each test. Now, let's run. Okay, so the test finished running. We see that it passed. In the screenshots directory folder, we see the file and it shows the application at the time of execution. Okay, so now that we have taken a screenshot successfully, let's take a screenshot of a failed test. And to take a screenshot of a failed test, we must implement the 𝑹𝒆𝒙 from TestNG. We add the interface as a parameter. 𝑹𝒆𝒙. Let's test result. And I'm going to import 𝑹𝒆𝒙. The purpose of 𝑹𝒆𝒙 is to describe the result of a test, such as providing access to the test status, the test method, its parameters, start time, and end time. For example, if I click 𝑹𝒆𝒙, then the interface opens up. At the top, we see each constant status starting with created. It also shows success, failure, skip, success percentage value, and started. In addition to the statuses, we see how to get the status, set the status, get the method, and get the parameters. If I scroll down the class some more, it shows a method for getting the start date for this test in milliseconds. Also, it shows how to get the start date for this test, how to get the end date for this test in milliseconds. Let me say that again. It shows how to get the start and end date in milliseconds. There's more methods in this class. We're going to implement this get name method. The purpose of get name is to return the test result name. Let me scroll back up. We will also implement get status, which returns the test status using one of these constants. Our test is going to get the failure constant. Okay, so let's go back to our test. And for our test, we need a condition that states if the test failed, then take a screenshot. So with that condition, let's write if I test result dot failure, which is the constant, equals test result dot get status. Then we're going to capture the screenshot. Next, we will take all of the screenshot code and paste it in the inside the if condition. So let's take all of this code, and I apologize because I wrote this in the wrong place. It does not belong in the test annotation. It belongs in the after method annotation. So let me take this back and go down to the after method and perform the same step of putting our test result, and that's my mistake. And we're going to add the condition. If I test result dot failure equals test result get status. We're going to put all of this take screenshot code inside of that if statement. And once we do that, we'll finish setting up our test to take a screenshot of only a test that fails. Now, let's also do the part of getting the name of the test. So I'm going to update the code after screenshots, and I'm going to skip a line and add the plus and remove the hard-coded screenshot of the file name of test simple form demo, and I'm going to write test results dot get name plus the type of file, which is PNG. This is all we need to take a screenshot of a test that failed. Recall our previous execution passed, so let's run and make sure a screenshot is not taken. And then I will come back and make this test fail, so we will see the screenshot taken. Test finished running. We see it passed. Now in the screenshot folder, it does not show a screenshot. So now let's make the test fail by verifying our tests does not equal each other in expected and actual results. I'm going to modify it by removing one of these exclamation points in the send keys method. Now let's run. And the actual and expected results should not match. Okay, the application shows 2 exclamation points. Let's see what the screenshot shows us. It failed. And we see how it says message is not LambdaTest is awesome with 3. Expected shows 3 exclamation points and actual shows 2 exclamation points. Now for our screenshot folder, we see the screenshot. When I double click it, it shows, yes, a difference between expected and actual. Your message shows 2 exclamation points. Okay, so that's it for taking a screenshot of a failed test. Thanks for watching how to take a screenshot of a failed test, and I will see you in the next video. And for the next video, it is dynamic wait statements using TestNG and Selenium. Dynamic wait statements from Selenium are a group of methods that pause execution between statements depending on a condition. The condition can wait for a specified time before throwing an exception, or wait for the element before performing an action. There are many web applications that have dynamic content, so we must implement a dynamic wait method. An example of dynamic content is when an element becomes available after clicking a different element. Another example of dynamic content is when an element becomes available a few seconds after loading the page. Selenium provides more than one dynamic wait statement. Thread.sleep is not a Selenium wait method, although it causes execution to pause. It is not efficient because execution will stay asleep for the time we set, even if the element is ready for action. The next 5 methods are dynamic wait methods from Selenium: page load timeout, script timeout, implicit wait, explicit wait, and fluent wait. When it comes to page load timeout, we set the wait time for a page to load before throwing an error. Script timeout sets the wait time for JavaScript to execute before throwing an error. Implicit wait instructs WebDriver to wait for all elements connected to the driver. Explicit wait will pause execution until time has expired or an expected condition has been met. We implement explicit wait by using the WebDriver wait class. Last is fluent wait. It allows us to wait for an element, check for the presence of an element, and ignore exceptions. Fluent wait is extended by the WebDriver wait class. In this tutorial, I will demo 3 of these dynamic wait statements: implicit wait, explicit wait, and fluent wait. Let's start with explicit wait. All of the code will be on GitHub. The application under test is from LambdaTest. And on LambdaTest, you will see Selenium Playground. With this application, we're going to start by clicking the dynamic data loading link. On this page, the AUT has a note that says loading icon will be displayed until the request is processed. The loading icon shows up after clicking the Get New User button. Notice how the image, first name and last name, is dynamic because it showed up a few seconds after clicking the Get New User button. Go back to the home page and let's copy the URL. Then go to the IDE and create our class. First, create our class by right-clicking the package demo TestNG, new Java class. The name is dynamic waits. Start by writing WebDriver driver. I'm going to import WebDriver and also insert some lines. Next, we're going to start with our TestNG annotation, and that annotation will be before method. Public void setup is the name of the method. WebDriver manager dot Chrome driver dot setup is how we set up Chrome driver. Now we create an instance of Chrome driver with driver equals new Chrome driver. At this point, we have the option of maximizing the window with driver.manage.window.maximize. Now we load the AUT with driver.get, then paste in the URL. The last annotation for setting up and tearing down is after method. And this will tear down our test by using the Selenium method of driver of quit to quit the drivers. Now we have set up the method for testing, and we are going to tear down the test. Now we are going to start our test. The name is test explicit wait. First step is to click the link. So we write driver.findElement by link text. For now, I'm going to put in an empty value, but the method is click. Go to the application and inspect dynamic data loading. We see the DOM has dynamic data loading as the text. So I'm going to copy, then go back to our IDE, then paste the value. Next step is to click the button. And the button we're going to click is that Get New User button. Inspect. We see it has an ID value of save. So let's go back to the IDE to write driver.findElement by ID, then write save as the value for ID. The action from Selenium is click. Bingo. Now we must verify the image is displayed on the application after clicking the button. Go back to the application under test, and we're going to inspect the image. We see in the DOM that the tag is img for image. The parent element has an ID value of loading. So to find the element, let's write 2 div, open and closing square brackets, at ID equals loading. And we must put the value between single quotes. We can also put the value between double quotes. Either way is okay, but I prefer single quotes. Now that we have found the parent element, and it's displayed by showing a yellow background highlighted in the DOM. Now let's find the image by writing 2 img. Bingo. We have found the image. Copy the value and go back to our IDE. Now we're going to write by image equals by XPath. Paste in the value. That's all we need to find the element, but we also need to make sure the element is displayed. And to find and make sure the element is displayed is writing a dot is displayed. My bad. Let's find that on the next part, because if I would have made this as a web element, I could have done that. So let's find the element by writing driver dot find element and then pass in image. Now we are going to see if the element is displayed. Bingo. Is displayed returns a Boolean value with a result of true or false. So since it returns a Boolean value, let's assign it to a Boolean with the name like is image displayed. Bingo. Now, at this point, we must assert that the image is displayed on the application. Assert true. Is image displayed? If it's not displayed, let's write a message that says image is not displayed in the AUT. I want to show you what will happen if we do not include a dynamic wait statement. So let's run and watch this test fail. There is a failure because the dynamic image was not available before our test executed the assert statement. In the console, we see assertion error with our message. Image is not displayed in the AUT. Let's write the explicit wait statement before the is displayed statement. So I'm going to skip a line. Then write web driver wait. Bingo. Wait equals new web driver wait. Then we're going to pass in the driver dot duration with an option to pass in a time unit. So far in the IntelliSense, we see a time unit of days, hours, milliseconds, minutes, nanos, and seconds. We're going to use seconds. And the seconds we're going to use as the value is 5. The test will wait up to 5 seconds before throwing an exception, or wait until an expected condition. And Selenium provides many expected conditions. And we're going to choose visibility of element located. Then pass in image. Now the test should pass when we run. Let's go up and run our test and see what happens. Yes, it's good. The test passed. Next, we're going to look at fluent wait. On Selenium's dev website, we're going to see the fluent wait class, and it shows class fluent wait. And the subclass is web driver wait. That means web driver wait extends fluent wait. Let's go back to fluent wait. And we are going to use the sample code at the bottom. So I'm going to copy, then go to our test script. Go back to the home page. The test script begins with us clicking the jQuery download progress bars link. Then click the start download button. We see start and download. The current progress with the percentage, then complete with the exclamation point. Our test will poll the values until we see complete. The test script will collect each value when it polls the application. Therefore, our automation code will print all of the values until it shows complete. The menu items on the left have the same values as the home page. So let's inspect jQuery download progress bars. It has a link text of jQuery download progress bars. Next step, let's inspect the start download button. It has an ID value of download button. In the IDE, let's start our test, which begins with the test annotation. Public void with the name like TestFluent, wait. Driver dot find element by link text, and the link text name was jQuery download progress bars. I think it was lowercase bars, and we click the link. Next step is to click the start download button by writing driver dot find element by ID, and the value was download button, and we also perform an action of click. At this point, we're going to paste the sample fluent wait code, then take care of all of this red. Import wait, fluent wait, no such element exception. There are two no such element exception packages, but we will select the package from org.openqa.selenium. Import web element and function by selecting the first package, com.google.common.base. Now we are taking care of all of the red. The comment statements, let's update these also. We see the first comment states waiting 30 seconds for an element to be present on the page. That comment is referring to the with timeout method, which sets how long to wait for the evaluated condition. Okay, let me say that again to make sure I did not mess it up. The with timeout method is a method that sets how long to wait for the evaluated condition to be true. The next comment says checking for its presence every 5 seconds. This comment refers to the polling every method. This method says how often the condition should be evaluated. The ignoring method will ignore the no such element exception. Let's modify the sample code. I would have changed the polling every method to of milliseconds. Then pass in 100 so you can see the progress and complete message when it's running. Also the comment, change it from once every 5 seconds to once every 100 milliseconds. The next comment, well, the other comment is okay because I'm waiting 30 seconds for the element to be present. Let's keep that the same. Now, the next update is change web element full. Let's change it to element. Therefore, the next one, I'm going to remove the return statement and write driver.find element by XPath. And I will come back and pass in the value. But for now, we're going to assign the value to web element and give it a name of progress. This will help us find the element, which is the progress bar. Okay, so we have that part done. Let's go back to the AUT so we can get the values. click the Start Download button. And I'm going to inspect the progress. It has a div tag and a class value of progress label. The parent has an ID value of dialog. So to find this value or this element, let's write 2/div, open and closing square brackets, at ID equal 2 single quotes. Within the single quotes, let's write dialog. Now we have found the parent. To find the element we need, let's write 2 more forward slashes. Div, open and closing square brackets, at class, because that's the attribute we need, equals the name of the class value, which is progress hyphen label. Bingo. We have found the element that we need. Let's copy the value. Go back to the IDE and paste the value. Now, at this point, after finding the progress, we want to get the text of each progress. So let's write progress dot get text. Assign the value to string progress bar text. The last modification is to write an if-else statement. Within the if statement, we write progress bar text equals complete with an exclamation point. That's what we're looking for. And we're going to write a print statement that says progress is complete. There I go. And we're going to return the progress. If this part does not show complete, we add else. If it's not complete, then we're going to write a print statement that gets the text of the progress. Bingo. And we are going to return null. Return null if the progress is not complete. Let's walk through the test script. The test script will wait up to 30 seconds for the timeout to expire or the condition to become true. The condition is when it is complete, show up on the page. Our code will poll every 100 milliseconds, which means it will continue checking the condition. The no such element exception will get ignored. We can also add more exceptions if we want to ignore more exceptions. Driver is the input parameter which helps find an element. The element is assigned to progress. We get the text, then assign the text to progress bar text. When progress bar text equals complete, the value is printed, progress is complete. Now, let's go ahead and run the Fluent test and see what happens. Bingo. I'm going to also adjust the application under test so you can see the progress when it prints. We see start and download and the current progress. At the end, it should show progress is complete. I didn't see it, but let's scroll down the console and see start and download. We see the current progress and it stops at 98. And at the end, it shows progress is complete. That's it for fluent wait. Next is implicit wait. Let's transition to a different website to demo the implicit wait. The website is called the internet, and the page is called Dynamically Loaded Page Elements. There are two examples, but we're going to click example 2. The next step is to click start. It's loading, and our test script will wait for hello world. Then verify hello world. Let's go back and copy the URL. In the IDE, let's write our test. Starting with the test annotation, public void test implicit wait. Now, most people add implicit wait in the setup method before loading the page by writing driver.manage.timeouts. Now, at this point is when we see the other dynamic wait statements. Right here is already defaulting to implicit wait, but we also have page load timeout, which is the dynamic wait statement for waiting for the page to load. And we also have script timeout, which is the script timeout, which is the one for JavaScript errors. Let's go ahead and write implicit wait. And with implicit wait, we have the option where we're going to pass in duration.of. And this gives us the options of the time units: days, hours, milliseconds, minutes, nanos, and seconds. But we're going to pass in 5 as the number of seconds. However, we should not mix implicit and explicit wait statements. It will not happen all the time, but combining both dynamic wait statements can cause an unexpected timing problem. If I keep implicit wait in this setup method and run the explicit waits, then they would run together. And we do not want to perform that operation. Therefore, let's comment out implicit wait. And we're going to add implicit wait to the test annotation at the bottom for implicit wait. By writing driver.manage.timeouts.implicit wait. And let's put the duration of seconds on the next line. Bingo. The implicit wait operates like a global dynamic wait statement. Do you see how the driver is located at the beginning? Driver lives for the life of the driver object. That's when we're dealing with implicit wait. It's global because it starts with driver and it lives for the life of the driver object. Therefore, it will wait for every statement that begins with driver. That's why it is dynamic globally. So let's load the page by writing driver.get and paste in the value. That's the implicit wait statement. Now let's go and copy the URL and paste the URL for loading the page. Next step is to click the example 2 link. Let's go back and inspect the link. We see it includes example 2 in the text. So we can easily use the partial link text locator from Selenium to find this element. So let's write driver.findElement by partial link text. And part of the link text is example 2. And we're going to click example 2. After clicking example 2, the next step is to click start. So let's inspect start. And we see it has a value of start, but the parent has an ID value of start with lowercase letters. But the text for the element we need is uppercase letters. So to find it, let's write 2 div, open and closing square brackets at ID equals start in lowercase letters. But we need the button. So let's write 1 / button. Bingo. We found the element and it is highlighted. So let's copy the value. Then go back and find it by writing driver.findElement by XPath, paste in the value. And the action we need is click from Selenium. At this point, we wait for hello world. So let's go back and inspect hello world when it becomes available. A few seconds, bingo. Hello world. The parent has an ID value of finish. So the one we need is hello world with the text, and it has an H4 tag. So to find this element, we write 2 / div, open and closing square brackets at ID equals 2 single quotes. And within the quotes, we write finish because that is the value. And we found the parent. Now we must find the hello world of text by writing 1 / H4, bingo, and we found the element. I'm gonna go ahead and include the text by writing 2 brackets, square brackets, text, parenthesis, equals 2 single quotes, then write hello world, exclamation point. Now we found the text. Copy. In the IDE, we write by hello world equals by XPath, and we paste in the value. String actual message equals driver.findElement, and the element we need is hello world. And we're going to get the text. Bingo. Now we have the method to get the text of the value. Next step is to verify that we have the actual message. Assert.assert equals. We're going to pass in the actual message, and for the expected message, we're going to write hello world with an exclamation point. If the messages do not match, then we say message is not hello world with an exclamation point. And let's also insert a new line. Let's make this test fail by commenting out implicit wait. So to show you how it works when it have implicit wait and when it does not have implicit wait. Comment implicit wait, then run. The test failed as expected because it did not wait for hello world. Let's scroll the console and see if we have an assertion. We see no such element exception. No, it failed because it did not get the text of hello world. So that's why we do not have an assertion error. Now let's remove the comment and run again. This time the test should wait for hello world if 5 seconds was enough. It's waiting, it's waiting. And it's waiting. Bingo. The test passed because it waited for hello world and it passed without a problem. That's it for dynamic wait statements, explicit wait, fluent wait, and implicit wait. Thanks for watching, and I will see you in the next video where we are going to cover the page object model design pattern. In this tutorial, we will walk step by step on how to create a page object model design pattern. It consists of page object classes and test classes. I will start from scratch with Selenium using TestNG annotations, TestNG assertions, and object-oriented principles from Java. Some of the concepts were covered in previous tutorials. All of the code from this tutorial and previous tutorials will be on GitHub. There will be 5 TestNG annotations. The annotations are before class, after class, before method, after method, and the test annotations. When it comes to assertions, they help verify our test. They verify if the test passed or if the test failed. In Java, there are 4 object-oriented principles. The principles are encapsulation, inheritance, polymorphism, and abstraction. Our focus will be encapsulation and inheritance. Encapsulation keeps the data and the code that manipulates the data safe from outside classes. Inheritance is a process that allows a class to inherit the attributes and methods from another class. Polymorphism is the quality of an object to take on many forms. Abstraction is a technique that shows some details and hides other details. Page object model, that is the design pattern that uses the object-oriented principles. The advantage of a page object model is separating elements and interactions from the test scripts. There are 3 benefits to using the page object model design pattern. Those benefits are reusability, readability, and maintainability. Now, let's create our page object model design pattern by going to the IDE. Let's create the page object model design pattern starting with the structure. In this project, we have a source, src directory, and it has 2 subdirectories, main and test. Main is used for the base page and page object classes. Test is used for the base test and the test classes. We will start with the main directory. Expand main, and we see Java. Right-click Java, new package. The name of the package would be LambdaTest.pages. And before LambdaTest, we write com dot. Now, let's create our Java class by right-clicking the package for pages, new Java class. The name of the class will be base page. The purpose of a base page is to have common methods for all of the page object classes. It's not required, but I recommend the base page because it helps with the dry principle. Dry stands for don't repeat yourself. We do not repeat the same methods in our page object classes by having a base page. For example, every page object class needs a driver. So we write public static web driver driver. Import web driver. After import web driver, we know the purpose of a web driver is to control the browser. Therefore, we set the driver by writing public void set driver, then pass in web driver. After passing in web driver, we're going to now write base page dot driver. equals to the driver. For Selenium automation, there are two key steps. The first key step is to find the web element. The second step is to perform an action on the web element. There will be different actions, but we will always find the web element. So let's create a common protected web element to find. The by class is used as a locator to find web elements. That's why I passed in by locator as the parameter. Import web element and also import the by class. The by class is used to find the web elements. So now that I have the by class, here is the interesting part. Web element is the return type because driver.findElement and pass in the locator returns a web element. That's why the return type is a web element. Let's go to the application under test, which is Selenium Playground from LambdaTest, and walk through the test script. From this home page, we will click the Bootstrap progress bar link. Click the Start Download button. Wait for the progress, then get the download completed message and 100%. Notice the test script will click the button and get a message. Let's go to another page like the jQuery download progress bars from the previous tutorial. In this page, we also click the Start Download button and get a message. The message we got in the previous tutorial was called complete soon as this percentage finish. So those two pages have two common methods. They click a button and they get a message. So for our base page, we are going to write a method for clicking a button, such as protected void click. Pass in the by locator. And we're going to find the locator. After finding the locator, we're going to click. This will click the button, but using this method, we'll click anything such as a link and a button. Do you see how I called find? This find method helps us to not write driver.findElement every time we are trying to find an element. Plus, we write less code to perform the same action. That helps with the drive principle that I mentioned for as don't repeat yourself. We do not have to repeat this same driver.findElement in our page object classes. We only need to call the find method the same way we called it in this base page. The other action for both pages was getting a message. Selenium methods. Selenium provides a method for getting a text from an application. So let's write protected string get text. Also pass in the by locator. And we find the locator, then get the text, which is that Selenium method I was just speaking about. It returns a string. So put string and with any name like text. Sometimes I like to print the value for debugging purposes. So let's write the statement for printing text, and I'm gonna write text after that part, and we're going to return the text. That's it for the base page. And with that part, we have the method for getting the text and a method for clicking. And we have that first step to always find the web element. And these are the actions, clicking and getting the text. Now, let's create the page object classes, starting with the home page. Right-click Pages, New, Java class. The name is home page. As a convention, I prefer to name the class with the same name as the application page. Here is the object-oriented principle of inheritance when I write extends base page. This means the home page inherits class members from the base page. Therefore, base page is the parent class and home page is the child class. Parent class is also known as the superclass, and child class is also known as the subclass. On the AUT homepage, our test script will click the Bootstrap progress bar. So let's inspect that link. We see it has an A tag, href attribute, and class attribute. Let's find this element using Bootstrap progress bar. Go back to the IDE and write private by Bootstrap progress bar equals by link text, then pass in that value. This is the other object-oriented principle of encapsulation. We make the variables private and the methods public. As a result, only methods in this homepage class can access the variables. For example, it is best to create a transition method. The return type is Bootstrap progress bar page, and the method name is click Bootstrap progress bar. So the reason why I create a transition method, and it's called a transition method, because on the home page, look what happens when I click Bootstrap progress bar. The page transitions from the home page to the Bootstrap progress bar page. Whenever you click a link or a button and the page changes, then it is best to create a method to reflect that change. That's why we call it a transition method. We finish this method by writing click. Notice the IntelliSense shows click by locator. This click method was created in the base page. However, the home page object has access to click because of inheritance. Now we pass in Bootstrap progress bar and return new Bootstrap progress bar page. And let me insert some more lines. Bingo. Bootstrap progress bar page is red because we have not created the Bootstrap progress bar page object class. So let's go back to the project and right click pages, new Java class, and the name will be Bootstrap progress bar page. It also extends base page. Go back to the home page object, and now we no longer see red because we have created that class. I spoke about how private means only methods in this class can access variables. A public access modifier means any class in this project can access the method. If I go back to the base page, we see public driver. We also see public set driver. They are public because we want all classes to access the driver. However, find, click, and get text have a protected access modifier. They are protected because we want only the page object classes in this pages package to access methods in the base page. It's all about protection to prevent code smells and spaghetti code. Therefore, the test classes will not have access to find an element, click an element, or get text from an element. In fact, our test classes should not have access to call the Selenium WebDriver APIs. That's a quote from Simon Stewart. Simon Stewart is the creator of Selenium WebDriver. Let's inspect the Start Download button. And it has a value of DWN capital BTN. So I'm going to copy this value, then go back to our IDE. The Bootstrap progress bar page. Then for the variable, let's write private by start download button equals by ID. Then paste in the value. Now that we have pasted in the value for the field, which is the variable, let's also create the method called public, if I can spell it right, public void click start download button. We're not going to pass in no parameters because we only clicking the button and it does not need any parameters, but the action is click. Then pass in the field name of start download button. After clicking the button, we need to get the percentage that shows 100%. And we also need to get the message of download completed message. Let's start by inspecting 100. It only has a p tag with the class attribute, and the value for the class attribute is counter. We can find this using CSS selector. So let's write the dot operator, the dot, because it is a shortcut for class. Then we write counter, and bingo, we found the element. So copy this value, go back to the IDE, then write private by progress bar percentage by CSS selector, then paste in that value, which is dot counter, then add the semicolon. Now that we have that field, we can write our method to perform an action, and we are going to write public string. The return type is string because it returns a string value. The name of the method is get progress bar percentage. And we're going to write return get text. And the text we want is from the progress bar percentage field. Recall, we must wait a few seconds before the percentage shows up. So let's write an explicit wait statement before we return the text. For explicit wait, we write WebDriver wait. Wait equals new WebDriver wait. And we're going to pass in the driver on the next line to make room so everything shows up on this screen. Driver duration dot of seconds. And the number of seconds we want to allocate is 5. That will be the maximum amount of time that we wait for the element. Now, we have our explicit wait. Last on this page, we want to wait until an expected condition. And the expected condition we are going to use is visibility of element located. Then we pass in progress bar percentage. And let's add this to the next line also, because it's way too far on that line. Now that completes the explicit wait statement. In the AUT, we have one more element to inspect, and that is the completed message. We see it has a P tag. The class attribute has more than one value. Therefore, we can verify this element contains only one value. How about we use this by writing 2/ P, which is the tag name. Open and closing square brackets, contains. Then the parentheses. Within the parentheses, we add the class attribute, followed by a comma, 2 single quotes. And now we're going to look for one of those values, which was success. That's all we need for using the XPath to find that value or that element. So copy the value and go back to our IDE. Now I'm going to write private by, a name can be completed message equals by XPath. Then paste in the value. Now we can go to our base test because we are finished with the base page, home page, and the Bootstrap progress bar page object. For the base test, that's when we include the TestNG annotations and take a screenshot. We covered the annotations and taking a screenshot in previous tutorials. Let's go to the test directory. Right click, Java, new package. Name is com.LambdaTest.test with an S. Bingo. Now we right click this package, new Java class, and this name will be base test. We start with some variables, and those variables will be private web driver, so we can control the browser. Import WebDriver. Next is protected base page with a reference of base page. After base page, let's add protected home page. Last, we're going to write the URL, which is private final string AUT URL, application under test URL. Final is optional. It makes sure we're not able to change the URL. Let's go to the application under test and get the URL after I import base page, import home page. Now let's go to the AUT and get the URL from the home page. Copy, and we paste the URL. For our base test, first annotation will be to set up our test classes. So let's write at before class, public void, set up, web driver manager .chrome driver .set up. Web driver manager automatically manages our driver. This helps us to not write system.setProperty. WebDriver Manager is more effective than system.setProperty because it automatically manages our driver. But system.setProperty, we have to manually manage our driver. Next step is to create an instance of Chrome driver with driver equals new Chrome driver. Bingo. After creating our instance, we can maximize our window with driver.manage.window.maximize. Bingo. The second annotation will tear down our test, and we do that by quitting the driver. After class, public void tear down. Now we write driver.quit. The next two annotations are for each method. These two annotations, before class and after class, were for the class. For the method annotations, let's start with before method. There I go. Public void load application. And we are going to load the application with driver.get. And we will pass in a URL, which has the value of the URL. Now, let's create an instance for base page. New base page. Bingo. After creating an instance, we set the driver for each test by writing base page dot set driver, then pass in the driver. The next statement is not required, but helps us to bypass creating an instance in every test. And we bypass creating an instance in every test by writing home page equals new home page. The last annotation for our base test is after method. And it will take a screenshot of each test that fails. Since this was already covered in a previous tutorial, let's go copy that code from this take fail screenshots class. And I'm going to copy all the way from public void to the last curly bracket and come back to base test, then paste. Bingo. Let's go ahead and just walk through this code right quick for people who may not have seen the tutorial that covered taking a failed screenshot. For the first, we get the status, and if it is a failure, then take a screenshot using the interface, take screenshot interface from the second statement. The third statement gets the screenshot of an output type for file, then assign it to source. Since we have a file source, we also need a file destination, which is the screenshots directory. If you want to, you really don't need to write file destination. You can only use new file to start your screenshot directory. The last part is the try catch block to handle the file by copying from the source to the destination. Let me go to the screenshot directory and give you an example of what was captured in that tutorial. If I go to screenshots, then open test simple form demo.png, here's a screenshot that failed. For our page object model test, let's right click the test package. I'm going to minimize that. New And then I'm gonna select Java class. And for our test, the name will be progress bar test. It will extend base test. Let's import the Bootstrap progress bar page with an object reference of progress bar page equals new Bootstrap progress bar page. The test annotation, public void test progress bar percentage. Now we write our steps. On the home page, we click the Bootstrap progress bar link. After clicking the Bootstrap progress bar link, our test will be on the progress bar page. From the progress bar page, we click the Start Download button. At this point, the progress bar page will take some time to return the completed message. And when we get the completed message, we are going to assign it to a string. Now for the completed message, let's go back because I did not add that part to our page object. I don't believe. Yes, we stopped at get progress bar percentage, but let's go back and get the message. So I'm going to come back to Bootstrap progress bar, let it run, and inspect the message. And we see, yes, I did put that. What happened, I forgot to write the method for getting the completed message. So let's add that part right quick. So I'm going to do it real quick and do public string get completed message. And I apologize because I forgot to get that message. And let's just copy and paste the explicit weight and change progress bar percentage to completed message. And we're going to return the completed message after we get the text. Bingo. Now for our test, we're going to get the completed message and assign it to string called actual message. And now that we have the completed actual message on the progress bar page, let's also get the progress bar percentage and assign it to a string called actual percentage. Bingo. Now let's walk through these steps right quick because I went back and I had forgot to write that completed message. So let's walk through this test right quick. On the home page, we will click the Bootstrap progress bar link. At that point, we are now on the progress bar page. And by being on the progress bar page, we now click the Start Download button. When the Start Download button is clicked, we wait a while, so we added the explicit wait statement to get the completed message and also get the progress bar percentage. The plan is to verify two values, so let's use a soft assert and not a hard assert. The difference between hard assert and soft assert is a hard assert will stop execution and will not continue executing the next assert statement. That's if it fails. However, a soft assert will execute all assert statements if there is a failure. So at the top, let's write soft assert. Soft assert equals new soft assert. After, we're going to put in the string expected message. Because we get to the point we're going to verify. The string expected message is download completed with an exclamation point and add the semicolon. The message for the percentage is expected percentage equals. Let's make it fail on purpose. So let's put 1000%. So we see it fails. Now for the assertions, we're going to put soft_assert.assert equals. And for the first one, we're going to assert is the message. We're going to make sure that the actual message and expected message are the same. On the next line, if they're not the same, let's write the message is not complete or correct. Now, this will also fail because download in the application is spelled wrong. And the second failure, we talked about that because it's going to have 1000% that we expect, although the application returns 100%. So for the soft assert, let's put assert equals actual percentage, expected percentage. And we're going to put the message on the next line. And the message would say percentage is not 100%. Bingo. Always remember to add soft assert all at the end. If assert all is not at the end, then every test would pass automatically. Now, let's run. We see a yellow icon because the test failed. In the console, we see assertion failures. One for the message is not correct, is not complete or correct. Expected download completed, but found download completed without the N. The other message is percentage is not 100%. Expected 1000%, but found 100%. We can also look at the screenshot. Go to resources, screenshots, and we're going to open up test progress bar percentage. In this screenshot, we see it shows 100%. Yes. And the completed message does not include the letter N. Let me maximize this just a little bit. Okay, so now let's make the test pass by going back to progress bar test, remove N from the expected message, and also make 1000% to be 100%. Let's run. This time the test should pass, but let's make sure. Yes, the test passed. In the console, we see the text that shows download completed and also 100%. That's it for page object model design pattern. Thanks for watching, and I will see you in the next video where we will talk about the parallel testing and data providers. Parallel testing is a process that executes 2 or more test scripts at the same time. Data providers allow us to perform data-driven testing. With parallel testing, our automation code can be set up to run each test in more than one browser, more than one operating system and more than one device. One of the benefits of parallel testing is to reduce execution time. With data providers, we are allowed to send as much data as we want to our test script. For parallel testing, the TestNG XML file has a parallel attribute that can be set to classes, methods, or tests. These three values determine how our tests are going to execute in parallel. I will also demo thread pool size and invocation count. For data-driven testing, we need a data provider annotation. In addition to the data provider annotation, our test script requires a data provider attribute or a data provider class attribute. A data provider attribute allows us to send data from the same class. The data provider class attribute allows us to send data from a different class. All of the code will be on GitHub. Now, let's get into our parallel testing. First, we create a class. So let me open up IntelliJ, the IDE, then right-click Demo TestNG, New Java class. Name is Parallel. Let me do it one more time. New Java class. Somehow it went away. Parallel testing is the name of the class. I'm going to now write web driver. Also insert some lines. No, let me put that back up and insert lines after the curly brace. Then import web driver. At this point, we're going to set up our test by writing @ before method, which is one of the TestNG configuration annotations. Public void setup. Now we write web driver manager .chrome driver .setup. Now create an instance of Chrome driver by writing driver equals new Chrome driver. The next step is to now tear down our test with the TestNG after method annotation. Public void tear down. Driver.quit is the method we need to tear down and close the browsers. Now, for our parallel test, we will load the page and print the thread ID. Let's go to our application under test, which is Selenium Playground by LambdaTest. I'm going to click jQuery date picker, then copy the URL, go back to the IDE, and begin the test by writing public void, and let's name this test_jQuery date picker. I'm going to now load the page with driver.get, then paste in the URL. For the print statement, let's make it thread.currentThread.getID. I'm going to put the next part on the next line so we can see everything within the screen. The name of the page is jQuery date picker page. Bingo. To break down this statement, we see thread.currentThread.getID. Thread allows our program to operate efficiently by performing more than one thing at the same time. Current thread is a static method that returns a reference to the current thread object. GetID returns the identifier of the current thread. Let's create one more test. How about list box, date list filter? I'm going to copy this URL, then go back for our next test. at test public void test2 underscore data list filter. Also load this page with driver.get, pass in the URL. Let's go back to test 1 and copy this URL. Copy this print statement. And I'm going to use the same information for test 2. But I'm going to update jQuery date page picker, jQuery date picker to data list filter page. And now what we're going to do at this point is create our TestNG XML file to run our tests in parallel. Let's go back to the project. Right click, new TestNG. The name of this XML file will be TestNG underscore parallel .xml. Bingo. The suite name will be parallel testing. We create our test in parallel. By writing this parallel attribute, we have options in alphabetical order for classes, false, instances, methods, none, test, and true. We are going to use classes, methods, and test. Let's start with methods. Also implement thread count equal to 2. Parallel decides if the TestNG will run different threads for this suite. Since parallel is set to methods, that means each method might run in different threads, although they are in the same test tag. Thread count is the number of threads to use when we run our test in parallel, and it's set to 2. Let's add test, the test tag, and the name is required, and the name will be parallel execution. Next is classes, and within the classes tag we write class. Bingo. Now when I run after this part, you're gonna see the taskbar show 2 Chrome icons. Let's finish setting this up. We start with the package, which is demo TestNG, then the name of the class, and the name of the class is parallel testing. Now I'm going to run and watch and see how parallel testing run, and watch for the 2 icons in the taskbar. The run window, it also shows both executions, test 2 and test 1. In the console, we should see 2 print statements with different thread IDs. Bingo. Thread ID 16 and thread ID 15 before the page name of data list filter page and jQuery date picker page. Next, we're going to change the parallel value to classes. Setting parallel to classes will execute each class at the same time. Let's create a class, a new class, to show you this example. So we have parallel test. I'm going to refactor this test and rename it to parallel testing 1. So when I copy this test, it's going to refactor the TestNG XML file. I'm going to copy parallel testing 1, then paste it, then rename parallel testing 1 to parallel testing 2. So now we have our new class, and I'm going to continue. In the TestNG XML file, we see it has been refactored to parallel testing 1. So now we have our two classes. Let's go back to the AUT. And we're going to look at another one. How about alerts and modal? And how about we use bootstrap alerts as the next one? Alerts and modals, bootstrap alerts. And with this, I'm going to copy the URL, then go back to our IDE, or to the IDE. Now, for the second test, I'm going to change test 1 to test 3, then rename it to bootstrap alerts, and also paste in the URL. Replace the one we have and paste in the new URL. Also, must update the page. The name from jQuery date picker to bootstrap alert message page. Now, we are finished with test 3. For test 4, let's go and find another URL. How about others? And then the drag and drop page. Copy this URL, go back to the IDE, change test 4 data list filter to drag and drop range slider. How about drag drop? And replace this URL with the one we just copied, drag and drop demo. Also, I'm going to update the page, the print statement, to show drag and drop range slider page. At this point, I can go back to the TestNG XML file, and I'm going to add the new class by changing parallel testing 1 to parallel testing 2. Now, let's run. And watch the taskbar again. You should see 2 browser icons show up. Bingo. Now let's look at the console. Both classes. Bingo. Okay, in the console, we see the print statements. We see thread ID before the page, bootstrap alert message page. Thread ID 18, jQuery date picker page. 19 is the thread ID, and that is drag and drop range slider page, followed by thread ID 18, data list filter page. We see a thread ID before each page name, and that's how we expect. It only showed 2 different thread IDs, thread ID 18 and thread ID 19 for all of the print statements. Okay, so now let's update the test, the parallel to test. Bingo. Test means only methods in the same test are going to run in the same thread. We will use the same 2 classes but create a new test by copying this first test. And before I copy, let me rename this here to first test. Copy all the way to the end test tag and paste. Change first test to second test. Bingo. Now, this time in the run window, you will see both tests execute at the same time with 2 different browser icons in the taskbar. And you will see a lot of tests show up when this execution finishes. You see the icons in the taskbar? And I think that is almost finished. It's a lot of tests. Okay, so let's look at the console. thread ID 18 and 19, 19, we're seeing a lot of print statements with thread ID 18 and 19. Bingo. Now, let's look at a couple of attributes for the test annotation. How about we go to parallel testing 2 for the test 3 method. I'm going to write thread pool size equal to 3, comma, invocation count equal to 4. Invocation count can be used for load testing, but for this example, we're going to use it to demonstrate a multi-threaded environment. A project will use this attribute to invoke different methods to determine if the code is multi-thread safe. Thread pool size depends on the environment, and it creates a thread pool to execute our test method by one thread. Let's run this class. And I will start from the class level by running this class. And we should see 5 tests show up. Test 3 will have 4 iterations and test 4 will have 1 iteration. So that comes to us seeing 4 different tests show up. And we'll see in the console if it has 5 tests or not. Scroll, and we see 5 tests in the run window. It shows 4 for test 3 and 1 for test 4. But let's keep on scrolling in the console to see if it shows us the same. Okay, this is 3 tests for Bootstrap alert message page. 1 more for Bootstrap alert message page. So that's 4 for test 3. And it has thread ID of 17, 15, 16. Yes, 3 different IDs. Let's keep on scrolling for the next test, and 1 thread ID for drag and drop. So that's our 5 tests. 4 iterations for test 3 and 1 iteration for test 4. The console shows the correct number of thread IDs and for the pages. That's it for parallel testing. Now let's perform data-driven testing with data providers. Let's go to the IDE, IntelliJ, right-click the demo TestNG package, new Java class. The name will be Data Providers Test. After adding the class, I'm going to write web driver. Also insert some lines, then import WebDriver. After importing WebDriver, the next step is to set up our test with the TestNG before method annotation. Public void set up. WebDriver manager dot Chrome driver dot set up. The next step is to create an instance of Chrome driver with new driver equals new Chrome driver. This time I will maximize the browser with driver.manage.window.maximize. After maximizing the browser, let's go to our AUT. And this time, let's go to input forms. Ajax form submit. We're going to enter a name, comment, then click the submit button. However, we are going to create our code to perform data-driven testing by entering more than one name and entering more than one comment. In the IDE, let's write the test. After the data provider annotation, this here is the data provider annotation at data provider. The purpose of data provider annotation is to return values to the test method. Those values will be returned as Java objects. Therefore, we write public, and we're going to write object with 2 square brackets. The name of the method will be Ajax data. Now, we're going to, on the next line, we're going to write object, 2 square brackets again, data equals new object. Let's add a 2 inside of these square brackets. The number 2 inside of the square brackets indicate this is an array of 2 object references. Next, we're going to write data in 2 square brackets again. Inside this square bracket, I'm going to add a, and then I'm going to add a 1. 0 and 1. This will be the information for the name. The name will be, how about Joe Doe? Next, I will write data, 2 more square brackets. This time, I'm going to write 0, 1. So I apologize. This is supposed to be 0, 0. This time, I'm going to write the comment, and the comment is tester, how about Joe Doe for the comment. On the next line, I'm writing 2 more square brackets, but this will be data 1, 0. The name is Jane Doe. And for the comment, I'm going to write 1, 1. The comment, tester Jane Doe. Bingo. And we're going to return the data. This example has an array of string values, only string values, but we can also store any type of value like a Boolean or an integer. That's all we need to pass more than one test data set to the test method. So for the test method, I'm going to write the test annotation. Now we provide the data provider attribute equal to the data provider annotation name, which is Ajax data. And let me show you the name of the data, the name of the data provider annotation. The name is Ajax data. And I pass in that name to the data provider attribute, Ajax data. The data provider attribute connects the data provider annotation to the test method. This is how both methods talk to each other. Let's write public void test Ajax form. We're going to pass in the string name and string comment. Also print the name and comment. Name, and then we're going to write name as the argument. Do the same for comment. And write comment as the argument. I'm going to add a few more spaces so the name and comment lines up with each other. Now, let's get the values for our test script by going back to the AUT, application under test. Inspect name, and we see it has an ID value of title. Inspect comment. it has an ID value of description. Let's also inspect the button. We see it has an ID value of btn-submit. Now, I've already copied the URL. Let's go back to the IDE so we can load the page with driver.findElement, driver.get to load the page and paste in the value. I apologize. I copied the URL, but then I came back and also copied Ajax data. So let's go back to the AUT and copy the URL. Then paste in the URL to load the page. For entering a name, we write driver.findElement by ID, and the value of ID was title. And for title, the name, we're going to send keys to enter the data. And we pass in name. Next, we're going to enter a comment by writing driver.findElement by ID, and the value for ID was description. Send keys. Then pass in comment as the argument. Last is the button. And with the button, we write driver.findElement by ID, and I believe the value was btn-submit. And with buttons, we click. Bingo. Now, let's run. We should see two browser icons in the taskbar. I just saw name Joe Doe. This shows Jane Doe. I'm going to close the browsers manually because I did not write driver.quit, because I wanted you to see that this here shows name as Jane Doe and the comment shows tester Jane Doe. I'm going to close this. The next AUT shows Joe Doe as a name and comment as tester Joe Doe. So that's how we perform data-driven testing. Let's look at the console. It shows name Joe Doe, comment tester Joe Doe. Scroll down some more and we see name as Jane Doe and comment as tester Jane Doe. Both pass in the run window. As a recap, the Ajax data method supplies data to the test Ajax form method, and the test Ajax form method is the test method. The data provider annotation provide two benefits at the same time. The first benefit is to pass an unlimited number of values to the test method. There is no limit to the number of values, and any type of value can be passed to the test method. The second benefit is to allow the test method to be invoked with different data sets. Each set would run and have its own test results. Notice the difference between the data provider annotation and the data provider attribute. The data provider annotation has an uppercase D, while the data provider attribute has a lowercase d. The data-driven testing was provided in the same class using the data provider attribute. Next, I will show you how to perform data-driven testing outside the same class. So to perform that, let's go to the TestNG library because I want to show you the information. Now, the data provider attribute class, the data provider class attribute allows us to separate the test method from the data provider into different classes. In the TestNG library, let me scroll down to the TestNG package. Bingo. And under annotations, we see data provider right here. That's the annotation. If I scroll down to the test, we see it has a data provider attribute and data provider class attribute. That's what we're going to pass into the test annotation using the data provider class attribute next. But first, let's walk through the application for our test. How about we go back to input form page. Let's go back to input form submit. Let's use this one. And on this page, all of the fields are required because it shows an asterisk beside each field name. The test script would enter a name and email. We're not going to click the submit button because the fields are required, but this should be enough data for us to perform data-driven testing. Let's go back to the IDE, and I'm going to create a new class by right-clicking Demo TestNG, new Java class. The name will be Data Provider Only. And for this here, I'm going to begin by inserting a line, then writing Data Provider Annotation. Then I'm going to write public static object and pass in those square brackets. The name of this method will be input data. And I'm going to write object, pass in those square brackets again to show it is an array. Data equals new object. And I'm going to pass in 2 inside of the square brackets. Now let's write our information for the data to perform data-driven testing. First, I'm going to write data in the square brackets for 0 for each one. The name, let's go ahead and just add Joe to repeat like we did in the last one. 1, 2, 3. I'm going to tab 3 times, and I'm going to write some more square brackets prefixed by data. 0, and this time I will add a 1. And for this here, I'm going to add the email of joe@gmail.com. For the second data set, I'm going to pass in 1, 0 equal to Jane. Data 1, 1, and the email for Jane will be jane@gmail.com, and return the data. Bingo. I just thought about something. You know how I said we can pass any type of data? Let's also pass in an integer. So at the end, I'm going to write data in 2 more square brackets, and with that, I'm going to pass in a 0. I gotta take out the num is on. So I'm going to pass in, okay, I'm probably with my laptop. There I go. I apologize about that. 0, and I'm going to pass in a 2. And the integer value, let's add 1. I'm going to do the same on this next line. 1 for the first square brackets, then a 2. And I will pass in 2 for the integer value. Let's also update the array. The last one, let's make it a 3. So the number 2 represents the number of rows, while 3 represents the number of columns. There are 2 rows, 1, 2, but 3 columns. 1 column, the second column for the email, and the third one has the integer values. There is one more concept we have for the option of providing a name for the data provider annotation. For example, we can write name equals input hyphen provider. It is not required, but it is a concept that we can follow if we want to provide a name for the data provider annotation. For the test, let's go back to data provider's test class. And I will add one more test. And this is where we implement the data provider class attribute. It's equal to the class name, which is data provider. Gotta spell it right. Data provider only dot class. At this point, we can include the other attribute, which is comma data provider. It can be the name of the data provider method or the data provider annotation. Now, in the last test, we used the data provider name, Ajax data, here. This time, let's use the name of the input provider. So I'm going back to data provider's test, and this time I will write input hyphen provider. Bingo. That's the name of the data provider and not the method name. So I'm going to start with public void test input fields. I will pass in string for the name, string for the email. Last, it would be an integer, and I would name it input number. Bingo. Let's make some print statements. First, it will be input number. The second print statement will be name. And I'm going to pass in name as an argument. For the last print statement, it will be email. Bingo. And let me add some spaces so it lines up together. Okay, now let's inspect the elements on the application under test. Inspect name, and we see it has an ID value of name. Let's inspect the email field, and it has an ID value of input email 4. That's cool. Okay, so I'm going to copy the URL, then go back to the IDE, and we're going to load the page with driver.get, pass in the URL. At this point, name is the next one that we're going to find. Next, driver.find element by ID, pass in the value of name. Send keys, and the keys we're going to send, name, pass in as the argument. After name, we're going to write driver.find element by ID, and the value was, I think it was input email 4. Send keys, pass in email. Now let's run. In the application, we should see Jane and Joe as the name. I see Joe at Gmail, and I see Jane at gmail.com. Jane for the name, Jane at gmail.com. Going to close this, and we see Joe at gmail.com. Both test looks good. and both tests pass. And if I expand this, we see it has its own value, data sets, Joe, Joe at gmail.com and Jane at gmail.com. Plus, it shows the values in the console. Input 1, name is Joe, email is joe at gmail.com, and the same for input number 2. Name is Jane, email is jane at gmail.com. That's it for parallel testing and data-driven testing. Thanks for watching, and I will see you in the next video for cross-browser testing using TestNG and Cloud Selenium Grid. Cross-browser testing is a test type that allows us to run the same test on more than one browser. For example, we can execute the test on Chrome and execute the same test on Firefox or Edge. It is a good way to analyze the test results. There is no limit to the number of browsers. With LambdaTest online Selenium Grid, we can run our automation test scripts on a cloud infrastructure containing over 3,000 desktop and mobile browser environments. All of the code from this video will be on GitHub. Let's start by creating a new class. Go on to the IDE, we right-click the package, demo TestNG, new Java class. The name will be cross-browser testing. Next, I will write public WebDriver, then import WebDriver, followed by inserting some lines. Let's also create a TestNG XML file. Right-click the project, new TestNG. The name will be TestNG cross-browser.xml. Remember to always include the extension of .xml. The name of the suite will be cross-browser testing. There will be 2 browsers that we're going to execute on, Chrome and Edge. Let's use Firefox. Now we can use Edge, either way is okay. Let's add the test tags. Name equals test on Chrome. There will be 3 parameters. The first parameter is browser with a value of Chrome. I will copy and paste the line statement 2 times. The second parameter is version, and it has a value of 103. The third parameter is platform. It has a value of Windows 10. At this point, we're going to have our classes by first adding the classes tag. Within the classes tag, we're going to write the class tag. And with the name, it always begins with the package, which is demo TestNG, followed by the name of the class, cross-browser testing. We are now finished with the first test. Let's copy the first test, and we're going to create the second test. Paste, change the name from test on Chrome to test on Edge. Change the value of the browser to Edge. Now we are finished with the TestNG XML file. Let's go back to the cross-browser testing class. We need the private string of user name, rex.jones. After username, let's add the access key, private string access key. and I will come back and enter the value for access key. After access key, we write private string hub. The value of hub begins with the @ symbol followed by hub.lambdatest.com /WD/hub. After hub, we write the desired capabilities, and it has a reference of caps, new desired capabilities. After desired capabilities, we're going to include the parameters annotation, followed by the configuration annotation from TestNG. And the annotation we will use is @before method, public void setup. Let's go back right quick and add the values for the parameter annotation. Value equals curly brackets, double quotes, and now we add the values of browser, comma, version, followed by platform. Bingo. If I go to the XML file, we see the same values as the TestNG parameter name: browser, version, and platform. Now, these values must be spelled the same. So far, our code has the parameter annotation values. Now let's add the setup method parameter values of string browser, string version, and string platform. These parameter values can be any name. However, I prefer to have the same name as the parameter annotation so it lines up correctly. Now, the method parameter values get their values from the TestNG XML file value. If I go back to the XML file right here, we see the value of Chrome 103, Windows 10 for both tests. The only difference is the value of the browser, Chrome and Edge. So now we are finished with the XML file. Let's go ahead and continue setting up Selenium Grid. The object reference of caps grants our test script to set the capabilities by writing caps.setCapability. Let's add the build with a name of 2.1. Bingo. Now, we have a way to set the name by writing caps.setCapabilities name. And the value will be cross browser testing. Add some more room. After the name, we're going to pass in the three parameters of string, browser, version, and platform by writing caps.setCapability browser name. And the value is what we pass in from the TestNG XML file to the method parameters. Browser. I will copy and paste it 2 times. Change browser name to version. And I'm going to pass version in as the argument. After version, I'm going to change browser name to platform. Then pass in platform. Bingo. We're going to set 3 more capabilities: network, console, and visual. All of them will be set to true because the default is false. Caps.setCapability. Network with the value of true. Once again, copy, paste 2 more times. Change the second one from network to console. Change the third one and last one from network to visual. Visual takes a screenshot of every test step. Console records the JavaScript logs. Network, it captures a recording when executing the test. In addition to the desired capabilities, let's also create an instance of remote WebDriver. We are not running our test in a local environment, so that's why we will not use Chrome driver or Edge driver. We create the instance inside of a try-catch block, starting with driver equals new remote WebDriver. Within remote WebDriver, we're going to write new URL in all caps. Then pass in https://2/ followed by plus. Let's make room by putting next information on the next line. Username plus the double quotes, colon. After the double quotes, access key, then hub. After this, we write caps. And that's it. After we import URL from java.net. Now that we have the try part finished, let's add the information for the catch. Malformed URL exception, exe, and we're going to write print stack trace. We will be finished set up on our Selenium grid after I write the driver.get statement so we can load the page. And I will come back to add the information for the URL. Now, let me show you a shortcut how we could have set up Selenium grid by coming to Automation Capabilities Generator. This site provides the shortcut of setting up Selenium grid. This page provides the ability to select a language of Java, Node.js, C#, PHP, Python, and Ruby. Also, we can select a framework of Java, JUnit, TestNG, and Selenium. Did you notice the sample code changing in the black box? If I change the language from Java to C# or Python, and the framework updates as well, we could have copied the code to set up Selenium grid. But for this demo, I thought it was best to create the code from scratch. After running our test, we can have the test artifacts such as the test results and screenshots and video will appear on this site. Let me navigate to profile and copy my access token. Bingo. Okay, go back to my IDE and paste the access key. At this point, now for our test. Go to the application under test, and we're going to go and walk through our test script on Selenium Playground created by LambdaTest. There will be two test scripts. The first test script involves clicking Selenium drop-down list from input forms. Then select a day from the drop-down. The next test script, we're going to navigate to others, then drag and drop. For demo 2, we will drag me to my target box to the drop here box. That would be our two test scripts. Let's investigate the page of Selenium of select drop-down list. Inspect the drop-down, and we see it has an ID value of select demo. Let's verify if it is a unique ID value. Control F, hashtag select demo, select hyphen demo, and we see that it's unique and it has been located with the yellow background in the DOM. Now, let's also go ahead and copy this URL so I can paste it so we can load the, you know what, let me go back and paste the URL, copy the URL from Selenium Playground. I think I copied it already, but I'm not sure. Paste, and now we have the page to be loaded, driver.get. For the test, we write public void test drop down. The first step is to click the hyperlink by writing driver.findElement by link text. And the text was select drop down list. And for links, we perform an action of click. Next is to find the drop down element by writing driver.findElement by ID. Select hyphen demo was the ID value. Then we assign it to web element find drop down. Let's import web element. And once we import the class, well, it's actually interface, but it shows import class. The next step, we need the select class to select a value from a dropdown. The object reference is day dropdown equal to new select. At this point, we pass in the web element of find dropdown. Let's also import select because I see it's red. Now the day dropdown provides access to 3 methods that allows us to select a value. We see select by visible text, select by value, and select by index. Let's use select by visible text. Then pass in Saturday as the day. This first test is complete. For the second test, let's navigate to others and drag and drop demo. Let's inspect the drag me to my target box. It has an ID value of draggable. Let's also inspect drop here. That box has an ID value of droppable. Okay, so going back to the IDE, we're going to start with our test annotation. Public void test drag and drop. First step is to click the link of driver.findElement by link text, and that value was drag and drop. Perform an action of click. Next is to find the draggable source box by writing driver.findElement by ID. It had a value of draggable. We're going to assign this to a web element, which is the source. Next, we find the other web element, which is the target. Driver.findElement by ID, and the target had a value of droppable. Okay, so now we have the source, we have the target. Next step is to perform actions with the reference of ACT equals new actions. We must pass in the driver. ACT provides a way to perform different actions. Let's select drag and drop. Then pass in source, followed by target. We must also add perform at the end so we can perform the action. That's it for the second test. Now that we are finished with both tests, let's run the TestNG XML file. In the run window, we see test on Chrome with both methods should show up. Test drag and drop. Okay, now let's go to the test drop down. Now we see test and on edge, and both methods pass for test on Chrome, cross-browser testing. Go to the Selenium automation build. And notice we see cross-browser testing 2 times and for Edge, and cross-browser testing for Chrome. Okay, and I'm not sure, but we can also do another thing for us updating this information. This here's the 2.1, the build that we saw. In this layout right here, we have the option of looking at a video and screenshots. Let's go ahead and click the name on the right side for one of the session names. And it's generating the test logs, and it shows the steps. We can also view the screenshot and parameters. View parameters, view screenshot. And it shows the screenshot. I'm going to close this. We also can watch the video. And if I increase it, it shows Saturday in the drop down. That's one part of the test. The second test have not came yet, but it's running and it's executing. So that's how we perform cross-browser testing using TestNG and Cloud Selenium Grid. Next, we will perform geolocation testing. Thanks for watching, and I will see you in the next video. Geolocation is short for geographical location. It refers to the use of an internet-connected device. That device is identified by tracking the physical location. In this tutorial, we are going to mark the geolocation, and I will show you 2 ways for changing the location to be in a different place. First would be the cloud-based Selenium Grid. Second would be the new Selenium 4 feature. I will show you how to perform all of this information and steps using TestNG as the test framework, and all of the code will be on GitHub. Let's start with the cloud-based Selenium Grid by going to this website created by LambdaTest called Automation Capabilities Generator. In this website, we're able to select a geolocation by any country that's located in this dropdown. We see that all of these options are countries. And within these countries, the sample code will update. Let's select the first country. And the capability name shows geolocation. Then we see the country as a value. The value is AL. We can also select other countries like Israel. And the value changes from AL to IL. Also, how about United States? That value is US. Now, at this point, we see a good use case for marking a geolocation. And that use case is when the application changes with different features depending on the location. To track my laptop, I will use where am I. This is a tool that finds the location based on map coordinates. Let's start by creating a new class. Right-clicking the package demo TestNG, new Java class. The name will be Geolocation _ Selenium grid. In this class, I will write public web driver, then import web driver. After importing web driver, I will also add the username by writing private string username equal to rex.jones. After username is private string access key. I will come back later to write the value for the access key. Next is private string hub equal to the @ hub hub dot LambdaTest.com /wd/hub. After LambdaTest, the hub, we're going to write desired capabilities with an object reference of caps. New desired capabilities. Bingo. At this point, we can write our configuration annotation, which is before class from TestNG. Public void setup. We're going to set the capabilities using the object reference of caps. Set capability. Normally, I start with the capability of build. This value will be 3.1. The order can be anything. It don't have to start with build, but I prefer to start with build, followed by the capability of name. This name will be TestGeo location. To save myself some time, let me copy this information because I can easily misspell the next values. Browser, let's go ahead and write the geolocation. Geo is in lowercase letters, but the L is uppercase. The geolocation will have a value of IN. IN stands for India. Next is the browser name. And the browser name that we will use is Chrome in lowercase letters, followed by the version of 103.0. After version, I would add the platform, which is Windows 10. After platform, I would add 3 more values, and the name would be network, console, and visual. For network, I would have set the value to true because the default is false. The same would be for console and visual. At this point, before loading the AUT, we're going to add a try catch block for the instance of remote web driver. And to create the remote web driver, I will place it inside try driver equals new remote web driver. Inside remote web driver, let's pass in new URL. Import URL, and we have the option of 2 packages, but we will select java.net as the package. Double quotes HTTPS:/2 : I will add the next information on the next line, starting with username, append the colon, followed by the access key, then hub. Last is the object reference of caps. We are finished with the try portion. Next is the catch, and we're going to catch the malformed URL exception, exe. Then we're going to print the stack trace. Cool. Now we are finished with the try catch block. We will load the AUT so we can track the device. And we load the AUT with driver.get. Let's go back and copy the URL so we can paste the URL. Copy. Since we're on this application, let's inspect the location. Location, my location inspect, and it has an ID value of address. In the IDE, let's paste the URL. We are finished setting up the test. At this point, let's create the test with public void test geolocation. Web element address. Let's find the address with driver.findElement by ID, then pass in the value, which was address. Next, we import web element and import by. Let's also print the information that we get with address.get text. Cool. Now we have one more thing to do, and that is to get the access key. So I would go to LambdaTest, profile, then copy the access token. Then paste the access token. After pasting the access token, we can run and see what shows up for our test. Let's go to LambdaTest first. Automation builds. And we see it's running. 3.1 is the build. Test geolocation is the name. We see the version 103.0. Platform is 10. We see Chrome as the browser, and it's running. So while it's running, let's go back to the console and see what it shows us. We see it passed with India as the country name because we passed in IN as the value. With LambdaTest, it's still running, but let's go ahead and view some of this information. It's generating the test logs. We see a video, username. We see the steps. We're able to report an issue, view the parameters, and also view the screenshot. If I view the screenshot, yes, and it shows us India as a country. Let's watch the video and see what it shows us. The video also shows us India as the country, so it's working as we expect. Next, we're going to look at how to mark the geolocation using the new Selenium 4 feature. Let's go to the IDE. And in the IDE, we're going to create a new class the same way we have normally created a class, by going to demo TestNG, the package, right click, new Java class. The name is geolocation _ Selenium grid. I apologize. This should be new Java class geolocation Selenium 4 feature. We already performed a test on Selenium Grid. Most of the times, when we set up in our test, I write web driver, but not this time. This time, we're going to use Chrome driver and import Chrome driver for the geolocation. That's why I'm using Chrome driver, because if we're going to perform a mock of the geolocation, the configuration annotation will be before method public void setup. WebDriver manager .chrome driver .setup. Now create an instance of driver equals new Chrome driver. And we're going to maximize the window with driver.manage.window.maximize. Yes. For this test, we type test as an annotation, public void mock geolocation. And know what? There are two ways to mock a geolocation. We have the option of using the execute CDP command or the DevTools class. We're going to use the execute CDP command to mock the geolocation, starting with driver.exec. Notice the parameters for execute CDP command. They are string commander name and map. So to give you some details of this here, let's go to Chrome DevTools protocol so we can see the method that will be implemented for the string commander name. Search for geo. And here's a list of 4 methods. Our test script will set the geolocation, so the second method has a description that shows overrides the geolocation position. Click this method, and now we see the parameters: latitude, longitude, and accuracy. These are the coordinates for the map. Let's go and search for the coordinates for the tallest building in the world. Okay. Latitude is always first, and the direction is north or south. Longitude is next, and that direction is east or west. The latitude is 25.1972 N, and the longitude is 55.2744 E. I will mark the geolocation with this information. Let's go and copy the URL from whereami.org. Then go back to the IDE. In the IDE, for the first parameter, let's write on the next line, execute emulation dot set geolocation override. And also I'm going to do the next part, which is the second parameter, and that is a map. So let's create the map coordinates equals new hash map. And for this, we're going to pass in the coordinates for the second parameter. But let's first import class and add these parameters of put latitude. And that value was 251972. and I see that we have this red information, and I'll come back and look at that later on why it's put longitude and put those in double quotes. And the longitude is 55.2744. And normally I always add 1 for the accuracy. And for the accuracy, I'm going to put accuracy 1. At this point, I have to go and investigate to see why is it showing us red for put, because normally I'm not used to seeing the red information for put. Coordinates, map coordinates, new hash map, put latitude 25972. Yes, so I have to investigate to see why it's doing this. Driver.execute, and I'm going to pass in coordinates as the second parameter, and I have to look at this again because I'm not completely sure why it's showing us red. It's saying add qualified coordinates to this here. So I have to just make sure. I'm not sure exactly. Okay, so the red is gone and it has a brown background. The last step is to load the AUT. And let me write driver.get and go to Geolocation Selenium grid and put in the information to load the AUT. And let's scroll and see if this information is correct. It looks good. So now I'm going to run. The location should be correct after we see the console and what shows up in this information. Bingo. It shows the correct location as the tallest building in the world. Let's also go to the console and see what the address shows us. It passed, but I did not print the address, but that's okay because the AUT shows the correct information that's in Dubai, because that's what we saw as the correct information. Okay, so the location is correct because we see the right latitude, longitude, and map to match the location. That's the first way of marking a geolocation. We're showing the correct latitude and longitude. Now, for the second way of marking a geolocation, let's go to Selenium's website. For the second way, it has a section called Emulate Geolocation that shows how to perform the same command using dev tools. First line, it creates an instance of Chrome driver. The second line gets the dev tools, then assign it to the dev tools class. Next session is created. That's when we create the session. After creating a session, a command is sent to emulate the geolocation by overriding the latitude, longitude, and accuracy values. Before quitting the driver, we see the location is loaded up with driver.get. That's how we mark a geolocation using the DevTools class. That's it. And thanks for watching how to mark a geolocation and the TestNG test framework. If you would like to learn more, then make sure to follow the blogs at www.LambdaTest.com/blog and community.LambdaTest.com. In addition to the blogs, you can earn a certification at www.LambdaTest.com/certifications. Get educated, get recognized.